That's good. That's good.
I can hear you just fine.
That's
Can
good.
you hear me?
Yes. Let me just make sure YouTube audio is good because sometimes YouTube audio is trash. Are you after work?
Yep, it's after work, and I'm gonna start doing my bricklaying project again.
What bricklaying?
That's what I've been doing after work for building a shed type thing. I've got a fancy tent I was given. It's like a teepee. It's like 13 feet wide. But because of the structure, it kind of needs walls, and I happen to have a shitload of bricks laying around. So I decided I was going to make like a almost a 13-foot wall, 13-foot wide brick circle, but it's not a circle. It's like I think it's got 11 sides.
Like, are you a builder? Do you know how to build?
Kind of.
Wait,
I'm
wait.
a welder.
You're a welder. Okay, you need.
I've never.
So you need an engineer to review, a concept. Make sure that this thing is not down on your head.
No, it's the roof is going to be the tent. The walls are just walls, and they're going to be about 3 feet high.
You can share the plans with me. I'll give you feedback. I'm familiar with construction. If you want feedback for free.
Let's see. Can I? Okay.
Let me see.
You can see me.
Yeah.
Can I switch my camera to the other one? So here's where I'm working.
Okay.
I'm just using sand as mortar.
Okay.
Sand and clay.
Okay.
But I think I'm gonna
do another
3 layers on top of this one.
Wait, so then there's gonna be a layer of cement?
No, I think I'm gonna do 3 more layers of bricks here, and then I've got a tent lying over there in a pile.
Hold on. What's gonna prevent this wall from collapsing?
So it's gonna be almost a circle. So it's pretty strong as is.
Right,
but it doesn't actually need to hold up any load at all.
Wait, but it's gonna hold a teepee, like a tent, like a circular tent?
The tent holds itself up, but the
tent
the walls of the tent.
That's not true. So the teepee has like these supports. They dig themselves into the ground. Vertical motion at ground level is prevented by the ground because the poles, they dig themselves in, so there's no horizontal motion. Your walls.
Yeah, it's not that kind of teepee. It's like it approaches a teepee, but it's got a vertical post in the center that holds up like a cone of fabric. So that's where the support comes from.
Oh, okay.
So it's only anchored to the ground via stakes on the floor. And then these walls are they're not structural.
Okay. Oh, but still, okay. I don't know. I mean, if you want to consult, if you want to show me like a drawing, whatever, or show anyone, I would recommend it. Someone that studied this seriously or has built, and because sometimes things collapse in very unexpected ways. So it's
if it collapses, it wouldn't actually be a problem.
Okay.
And it's not that serious a project, so I just decided to wing it. And then I can learn bricklaying along the way.
Okay.
And I'm using the clay sand mixture because 1, mortar is expensive, and 2, in case I need to rework anything, I can just take it apart and wash off the bricks with a hose.
Good enough.
And reuse them.
All right, let's get moving with the topic. So, what's your favorite from my list of propositions that you feel the most objection to, I guess?
So I think you get quite a lot wrong on Einstein. I think you have a number of interesting takes on um, relativity and physics. Um, I'm I'm not entirely sure I followed exactly what your take is on black holes, but you've got some. Here, I'm pulling up your site now. Um, yeah, black holes cannot grow inside the event horizon as a Planck-sized black hole. I'm curious what you mean by event horizon if the black hole itself is not the event horizon. Entry points into another universe. I feel like there's quite a bit of
No. So pick
extrapolation you could
just
go
one.
into there. However,
Pick one
I want to
topic.
give you the
Pick one.
first one is number 19. Smoking in moderation might have many health benefits.
Wait, of all the physics, you'd go to smoking?
Well, I feel like this is going to be the shortest one, so we can just
What
start here and
what do
then we'll
you
go
have?
to
What
go
do
to
you
the physics.
what do you have the most objection to? What do you feel like you can mop the floor with my face with? Which one would serve you best to mop the floor finally with my ugly face? What am I the most wrong about? Why don't you pick something that I like? If I contradict Einstein, that seems like a sure bet, no?
Um, I mean, it could be, I guess, but that's not necessarily my
So
my intention. I feel like
you think I might be right when I go up against Einstein?
no, I do think you're wrong, but I do think that you have some ideas that I don't fully understand.
So ask me.
So I do want to
But if I
pick your brain on them.
but if I contradict Einstein, let's talk
But,
about physics. I don't want to talk about smoking. Smoking is boring. Smoking is very healthy, like everything else. If you do it moderately, it's very simple. It's got health benefits like
so that if you want me to choose a topic on which I could wipe the floor, I feel like the smoking one
no,
is
that's
the easiest to
no,
defend against.
no. No. Smoking is very healthy, like everything else, in moderate amounts. As long as you enjoy it, you go out with friends and you smoke. You take deep inhales. You take breaks during
Uh,
the day. There's plenty of benefits. It's a social. People who smoke
oh,
do it socially, so it helps break social tension. Originally, it was invented as a social, as a peace. It's a peace offering. So that is what it is till to this day. People who
oh,
smoke,
I suppose you never actually mentioned here. You're talking about smoking cigarettes, which is what I assumed. Is that
it
is
doesn't
that a bad assumption?
it doesn't matter what you smoke. You can smoke anything. Actually, the tar that you smoke fills your lung and occupies your lung and lets we live in too clean of environments. We're not naturally suited for such pristine environments, which creates allergies. So if you smoke from a young age, or if you're exposed to smoke from a young age immoderately, that's a good thing. That's natural. And that employs your self-defense systems in your body, keeps them busy, keeps them healthy, so they don't overreact to a grain of dust and give you an allergy as we get in modern times. So I think my theory is that some of the allergies are because we're just too clean, and our defense systems are too hyper vigilant because there's nothing dirty to actually attack. So they jump on the first. It's not my theory. I mean, I've heard this theory from experts in allergy. Anyway, when you smoke, you fill up your lungs. You actually, like most people, don't ever take deep inhales, and their lungs shrink over time. If you exercise taking deep inhales, then you're actually growing your lungs over time. Smoking is a type of meditation. It's a perfect meditation because you're imagining it's the clean air coming in or whatever. You're imagining it's people who smoke. You can see that they relax just by the activity of smoking. Anyway, there's just plenty of health benefits. I'm not saying that over smoking is healthy. I'm just saying if you smoke a little bit here, a little bit there, it's terrific. That's all I'm saying. I'm not saying start smoking every day a pack or two. Definitely not. I don't do that. Like I smoke.
Do you smoke cigarettes?
Yeah, and like social events, and if once in a while I try to smoke more, but I hate the smell. So after I smoke, I need to literally wash my nostrils because otherwise I just can't function. The smell kills me. Now the
That's
problem.
interesting. Have you ever smoked? Have you ever smoked habitually, like a pack a day?
No,
Because
no.
I used to be a pack a day smoker for several
I
years.
I've tried my entire life to become addicted, and I just couldn't do it. Did I just you have to keep it up, and I just can't. It's too much of a hassle. But now the problem with the cancer, I think, is not just over smoking, but when you smoke and you heat up the actual filter, that is very dangerous. So that you should watch out for. So what I do is I dip the filter in water before I light a cigarette. So the filter cannot burn. Even if I smoke the cigarette to the very tip, I can't burn. It's very difficult for me to burn. And also, some of the tobacco is also wet when I dip my cigarette in water or my cigar. Anyway, and then you strengthen the filter, but you also prevent the filter from burning, and then you're really defending well against creating all these carcinogens. Anyway, look, the fact is that we live in
I
a.
don't. I don't think that that's. I don't think that that's true. So the filter is made of fiberglass, and it won't burn anyway. But the carcinogens are mostly a product. So I think obviously there's tar. If you burn plant matter, you always get tar. But then there's also like different chemicals like benzene, formaldehyde, and trace amounts. And you like there's 700 or something known carcinogens. These are byproducts of burning any plant material. And the
I
problem with
agree.
cigarettes is just that if you
I
smoke them enough, then you're getting
Yeah,
these trace amounts
I
over and over again.
I agree. Look, we're not disagreeing. Obviously, don't smoke a lot. Don't smoke. I wouldn't even smoke. Not every day. Not even every week. Like I would in social gatherings, you can smoke a couple of cigarettes. Like if you sit and drink a beer with friends and they smoke, you can smoke. Don't do it like the ancient ones did. Like imagine you do it only like as a peace offering. If you do it when there is a real reason to do it, when it's really really enjoyable. Don't overdo it.
I mean, I'll agree with you on that one. In fact, I think that there's a. It used to be that prior to e-cigs and like Zen and all the other shit. If you work in a restaurant or you work in any kind of service industry, then you get a break to go smoke a cigarette. In fact, I can't prove it, but I suspect that the reason that like California gives you one 15-minute break every 2 hours of work and one half-hour break after four, it has to do with that's about how long a habitual smoker would go between smoking a cigarette.
Hmm.
And I think that in doing so, especially men, don't generally just go talk to one another, but there's like always a smoker's table. And if you need to go smoke a cigarette, you go out to the smoker's table, and there's other guys there, other people there who are also smoking cigarettes, and then you can, like, you make friends, you socialize,
Exactly.
because you can
Like
kind of both pretend
like
that you're
tonight. Yeah.
not here to socialize.
Tonight I went out dancing. So then I went outside and I didn't take the lighter with me because it's a hassle. So I just took a pack of cigarettes. And then I didn't have a lighter, so I walked up to a couple of chicks and I asked them to light. So they literally I had to come face to face with her hand to light my cigarette, and then I had to ask another chick. So it's terrific. It's a terrific way to meet girls. You just they smoke, you smoke. It's a very natural interaction. It's like having a dog and meeting chicks with using a dog, using a puppy. So it's got many many health benefits and other benefits. So and don't forget.
So I would disagree that that you get health benefits from that. I mean, I think socializing gives you health benefits probably. So I'd agree there, but
So
I mean,
that's what I
I
mean.
think,
That's
you
what.
know, inexorably, you're going to harm your health by smoking cigarettes,
Not
no matter how
no.
infrequently. But more than that, I think that what you're talking about, maybe I'd actually loosely agree with you. However, I would disagree that um, any any meaningful number of people that do smoke cigarettes smoke them in that way. I think the vast majority of people that are smoking a cigarette are habitual smokers that smoke, you know, probably somewhere close to a pack a day
Yes.
regularly.
Yeah. I'm not talking about that. I'm definitely not that. Anyway, let's switch on board. Let's switch to something like more interesting. What else do you feel like you can mop the floor with my face, please?
Okay. Um, so, what's your feeling on black holes? So, you said that there exists a Planck-sized black hole in the center of the event horizon. And you discussed spaghettification and time dilation and a lot of Einstein stuff. So I'm pretty sure that you're familiar enough to know that the way that black holes are typically defined is by the event horizon. The event horizon itself is the black hole, and possibly the Hawking radiation and the effects that are near the event horizon, possibly even like the accretion disk.
No, I don't care.
But
But I don't care about.
what exactly do you mean that there is a Planck-sized point at the center of the event horizon that you call a black hole, and how does that differ from the typical understanding of a black hole, given that the event horizon is typically how we think of it?
So typically, if you listen to YouTube lectures about black holes, so they say, yeah, there is an event horizon. It's not clear what that is. I mean, there's many misunderstandings about the event horizon. Look, let's start step by step. So ask me one question and I'll answer, and then we can debate that. So like, there's too much. Like I have lectures about black hole formation and black hole. The equations of black holes. So you got to be more specific because I don't know where to
Okay,
begin.
so I would call the black hole itself. Do you agree that the event horizon can grow as the black hole, or as the event horizon um,
Yeah.
takes on more matter, that the event horizon grows?
Well,
And so I
hold,
would call the event horizon the black hole itself.
you could do that.
What would you call
Yeah,
that?
you could do that, but I'm referring to. So I don't care so much about an existing black hole. I care more about something no one ever discusses, that or hardly anyone ever discusses, that is the formation, the black hole formation, the very formation of a black hole. How can we have a thought experiment, a Gedanken experimentchi, whatever? How can we do a Gedanken, a thought experiment, and construct a black hole in our thoughts? That's what I'm interested in. I don't care for the finished product because then it's too late. I don't know what's inside. But if I can start from any first principle, like I don't care, even from a star, we can start even from the sun. We can start from anything, theoretically, even from the Earth. So I want to start from anything and create a black hole step by step from that. So if we would do that,
Okay, so
mhm.
yeah, go ahead.
So if we would do that, so let's start from a normal star. So a normal star. Let's start from a binary system. So we have two stars. One of them is a little bit heavier. So over time, it starts sucking in gases from its sister star and starts growing. Now it's becoming heavier and heavier. Let we're gonna do this slowly. So it's becoming heavier and heavier. It's gaining mass. And let me ask you this: where in this star that is growing? Right, we have one of the twin of the binary system. One of them is growing, and the other one is shrinking. So the one that is growing, for example, where would you say is the highest pressure?
Uh, it depends on what you mean by pressure, but I already have an issue with the thought experiment here, because if you have a binary star system, you have two entities. If they get close enough together, so are you familiar with the Schwarzschild radius, or how Saturn got its rings?
Yeah.
There was a moon that got shredded.
No, but it's a thought experiment. Forgive me for, it's just a thought. We could also go to a star and just dump slowly gases on it. We can manually bring just gas tanks and dump them onto the sun. Let's say we go to the galaxy, we get gases, like we get hydrogen or whatever, yeah, hydrogen, and just or helium,
Yeah. Okay.
and just slowly dump it on the sun. This is just I want to slowly
So
create a black hole. So first question is,
so the
mhm.
so the pressure would be greatest somewhere in between the surface and the core, but neither the surface nor the core, because the radiation pressure of the fusion from within the star is what holds, what exerts pressure against the force of gravity, pulling it into a more compact point. And
Wait,
and stars grow over their lifetime. So, for instance, the
hold on,
sun will eventually become a red giant because it
hold on.
starts fusing heavier elements,
No,
which
no,
generates more radiation pressure.
no. Okay, let's take the Earth. Where is the greatest pressure when we look at the Earth? Where is the location of greatest pressure?
Within the Earth, I would guess, although I wouldn't be certain, I would guess that it's in the core.
What do you mean in the core? Where exactly? Give me the very location where where the pressure is the highest, and why is it the highest there? If you want,
Uh,
I'll gladly help you, because I see that you've never gone through this thought experiment. Unfortunately, you see, no one discusses black hole formation. There's so many videos on YouTube about black holes that are like they go into so much detail about all the nonsense, but they never go through the thought experiment of creating a black hole from first principles. Start from a grain of dust and create slowly a black hole out of it. It's not that difficult. I have lectures about it and I know
uh,
nothing. You just have to go through the thought
well,
experiment. Yeah, go ahead.
I'm not sure that I fully agree. So, for instance, if you took the Earth and you just added
No,
more solids,
no,
say silicon
no,
dioxide, sand to it,
no,
eventually you will
no,
form a star. You'll get
no.
fusion in the core, which
Hold on,
generates radiation pressure against gravity.
hold on. No, we gotta. I asked you a question. I need the answer, because without this answer, we're not gonna be going anywhere. And I need this. This is critical. I need your input. I need to make sure we're synchronized on this. If we don't agree on this, I need to know. Maybe I'm wrong. I need you to tell me.
So, correct me if I'm wrong, but I think where you're going is that if we exclude things like tidal forces, plate tectonics, internal dynamics, or whatever, then there's a infinitesimally small point that is the precise center of mass of the Earth, where pressure would be greatest as gravity is pulling everything towards that one point.
So, are you certain of this?
Uh,
I agree with you. I just want to.
no.
Yeah, look, it's my opinion. So you mean no, yes. So just tell me.
So,
Mhm.
I mean, so like let's imagine we know precisely where that point is in the real Earth. Then if you go ever so slightly outside of that point, I think that the gravitational force there would be imperceptibly different than the actual center. However, there's obviously the core is solid, but it's not completely stationary. And so as plates move,
Hold on,
as the mantle
hold on,
turns and
hold,
whatever, there could be higher pressures that aren't the center.
hold. 1 second. Okay, let's not start from the Earth. Let's start from a grain of dust. Okay, we have a dust cloud in space. Naturally, these dust particles, because of gravitational attraction, they're going to start attracting each other, right? No,
Mhm.
but You didn't hear what I said?
Yeah. So for a grain of dust, I would agree that there is a center point. We could think of it as a point from which all of the gravitation originates, and that would likely be the highest pressure.
No, wait.
So if we add more dust, yeah, I'm following you.
Okay, so we have a grain of dust, and then it comes together close enough, and it picks up another grain of dust. Now you have two grains of dust, and now this is a greater mass than other masses, so they attract more and more, and the rich get richer. So this grain of dust is now picking up more and more and more and more and more dust particles, and it's growing and growing. Just more and more dust particles are coming to coalescing. Okay, so it weighs now a ton, 1,000 kilograms mass. Where would the greatest pressure be, and why? What is the pressure at the
I
what
think
is the pressure of the surface of this newly formed asteroid? Or
I think it would be quite low. But I also think that once you get more dust, you get more complex forces that make it not necessarily true that the absolute center of it is the point of highest pressure.
wait, okay,
So, for instance, if we let's imagine just two rocks, two irregular shaped rocks in the middle of space, and they're perfectly solid. There's no internal dynamics or anything to account for. For both of them, the center of mass would be the highest pressure. But then once they touch each other, then you've got like pressure is force per unit area. And so if you've got little jagged edges on these rocks, then
okay,
where they're
I'm
touching
lost.
each other would be of higher pressure.
I'm lost. Look, I'm trying to create the simplest thought experiment. That's why it's the simplest that I can make, and you're creating a complex thought experiment. But I want a simple thought experiment. So let me draw. Can you see me drawing?
Okay, so tell me what you mean by pressure.
I mean, pressure, as you said, is force per unit area. So here is this protoplanet asteroid, kind of circular, kind of spherical. This is the cross section of it.
Are you drawing?
Yeah, you can watch my stream, and maybe that would be the easiest. I'll give you the link. 1 second. You on
Do
your
I?
I don't know if you.
I am, but I'm also doing the bricks project. I'll watch if you need me to, but
I mean, I'm drawing to help you understand my question, and so we can, have a good discussion. Anyway.
okay.
Look, the pressure at the what is the pressure at the surface of this protoplanet? I need a number. Like, how many force newtons per meter squared? Let's say this thing weighs 1,000 grams, 1 kilogram. This thing weighs 1 kilogram. That looks like 1 rg. This thing weighs exactly 1 kilogram, and it's 1 meter radius. Yeah. What is the pressure here?
Let's see. Hold on, I am loading.
What is the pressure at
I'm
the
seeing.
surface of this protoplanet? The tiny planet.
I'm not seeing anything. I'm just seeing white.
So you gotta scroll out.
But I can see the thumbnail.
Yeah, you gotta scroll out.
Oh, okay.
Yeah.
So it weighs 1 kilogram. It's a meter in radius. What's the pressure on the surface?
Yes.
You could.
The pressure at the surface is irrelevant of the 1 kilogram and 1 meter. These are just numbers. You can change the numbers. I mean, so I'll okay. So I'll give.
Well, I mean the pressure would be proportional to, like, you could do the calculation with g, and you could figure out how much gravitational acceleration is occurring at that surface. And if you're standing on it, then the pressure would be.
No, wait. wait. No. Look.
Am I misunderstanding?
Yeah. Pressure is force. Here is a force, but there is no force here. The force here is equal to 0. No one is standing here. Force here is 0. So on this area, let's say 1 centimeter squared, there is 0 force. So what is the pressure? Definition of pressure is force per area. The area is 1 centimeter squared, but it doesn't matter. I mean, then it's irrelevant.
Uh,
The force is 0.
okay,
0
I follow you.
So what is the pressure? What is P?
Then there would be no pressure in, yeah.
So what is the value? What is P equals what number? Choose the number between negative infinity and positive infinity. What is the number? What is P?
So 0. There's
Exactly.
no
Yes.
pressure exerted on the surface.
Fantastic. All right. Good job. Good job. But this is going to be a very, very long discussion at this rate. This is going to be because I think you forgot your physics from high school or something. So it's going to be a very, very long discussion, and I've already had this discussion maybe once or twice. So
well, you want to build up to a black hole. My contention with that is that there are lots of complexities, I think, that are not being accounted for. But we'll leave that for later.
We're ignoring any.
So how do
we're just treating the mass. All we care for is the mass. So this thing
okay.
is 1 kilogram. When this is the pressure at the surface is 0. Where is the maximum? So, but if you go, let's say you go 10 centimeters down to here, what is the pressure here?
Right. Would be higher.
Yes.
Still very, very low, but higher.
Yes.
And then you would reach a maximum right at the center.
Very good. So that's all I wanted. The good. So this is max pressure. Whatever the pressure is, this is P max. Okay. You can either call it the center or the epicenter. Okay. All right. Okay. Now let's talk about what is there. Let's talk about what's there. So we said this is just dust. So let's make this now 1 million, 1 billion, 1 trillion. Or
so I would disagree there. If it's not a single solid object, then there would be places of higher pressure. Let's see. Can I draw? Oh, I can draw. Can I undo that?
Yeah, you have undo.
Okay, there we go. All right. How do I? So let's say we have two rocks like this, and they're both exerting gravitational force on each other, right?
No.
Well,
No. I want a simple thought experiment. Why are you going to complex stuff? No. I want metric.
Because I think you can't scale this up without introducing those complexities. But you see what I'm saying here, right?
We're gonna end up with a purely with an isomorphic, whatever. It's completely symmetrical object. It's a complete ball. I want to build a perfect ball of dust, that later becomes the Earth, and later becomes the sun, and later becomes a neutron star, and later becomes a black hole. I just want to do it slowly in stages. There's no reason to have two rocks.
But that's what I'm saying, is that once you increase the complexity, then you get the mantle is spinning, creating pressures.
Okay, so let's just add,
I don't think that makes sense.
So we're adding just hydrogen. Okay, well, no, it's not rotating. We're adding just hydrogen, and it's not rotating. This is a non-rotating asteroid.
But there's no such thing. It would be convective forces. As it heats up, as it gets closer to the core, then it loses density and then rises up, and then you get those convective forces. So if we're talking about the sun, then that's where sunspots come from. That's why the surface of the sun is not constant.
Assuming non-rotating, we're simplifying the
But
discussion.
then also the other thing is, once you get large enough to start fusing in the core, then you get radiation pressure that's forcing against the force of gravity.
Yeah, but you know that we're going to be discussing later a neutron star, so there's no activity, and then it's going to be a black hole, and there's like even as a neutron star, there's already no fusion, so it's a dead star. It's neutronium, pure neutronium. So we don't need that. So you can forget about all the complexity. A neutron star is is completely homogeneous, just neutrons. So let's imagine.
Okay, that's interesting. Yeah. Okay.
Okay, so let's
No
now.
fusion in a neutron star. That does seem
No,
true.
it's pure neutronium. It's just nothing but neutrons. There's no molecules. Just it's a single atom. A neutron star is a single atom. So
Huh.
the religious
Yeah,
people,
that does
they say
sound right. Although I'm not sure where the energy would come from if it's not fusion, if it's not turning mass into energy.
there's no
But
energy. It's there's no
I'll
energy.
accept that,
But
because I don't actually know.
there's no energy. It's going to cool down. It's going to cool down over time. It's going to become dead. It does not produce energy, as far as I know. It can't, because neutrons, as far as we know, don't decay. So there's no decay.
Oh, interesting.
Yeah,
So it's hot from the supernova,
yeah,
and it's irradiating that heat, but it's not actually creating any.
yeah.
Huh. Okay. I'll take your word for that.
Yeah, they usually rotate really fast, so
and
they create.
and then in that case,
Mhm.
yeah, neutron stars are weird. I haven't studied them.
No, they're very simple. No, they're very simple. Let's imagine a non-rotating neutron star. So, let's imagine it's
So
completely.
in this case, yeah, I'll totally buy it that there's a point at the center that is the maximum pressure of gravitational forces. No radiation pressure, no complexities like that.
Okay. So So at the
So
center
we're
of a what do
on
we
the same page.
have? Okay. So what do we have? What is the name of the particle at the center of a neutron star? What's the name of the particle?
Wouldn't it be just a generic neutron?
Yes, that's exactly. Here it is. This is the neutron at the very center of the neutron star. It has it. What is the pressure out of all the neutrons in the neutron star? What is the pressure that this neutron is experiencing?
It would be quite high. It would be some function of gravity
No,
of
no,
the mass of the body, the neutron star.
no. I just want an ordinal, just relative to the rest of the neutron in the neutron star. Is it the maximum pressure? What is the pressure it's experiencing?
Oh, it would be the max.
Okay, so
Yeah.
all right. Okay, so good. So now let's imagine this neutron star. Sorry, this neutron. So relative to the original neutron. So in the beginning, you had an original neutron. Now you have this neutron, but this neutron is under pressure relative to a neutron that does not have any pressure. Meaning this neutron necessarily has been compressed. So relative to a free neutron, this neutron is smaller. Would you agree with that?
I don't know about that.
Well, what is
I don't know if that's it. It would be more pressure would be being exerted on it, but it would still be the same size. I don't think the size of a neutron can change. I think that's dictated by the strong and weak nuclear force.
Hold on. So a neutron, we know what a neutron is. A neutron is just 3 tiny quarks and 3 tiny gluons. And these things are flying around, I think, really fast. These things are bouncing around. There is no shell. The shell is it's an illusion. Neutrons don't have a shell. Neutrons are just 3 particles, 3 quarks connected by 3 gluons, just bouncing around. That's what a neutron is. There is no shell. But you could say because it's bouncing around so fast, you can imagine that it looks spherical. It looks like a ball. Basically,
Sure. Okay. And so you're saying because of the pressure, then these um the mesons, um
the quarks.
no, the fermions, the quarks, the fermions would be bouncing around closer than if there was no pressure.
Exactly.
And so therefore, okay.
Okay. So some force.
And so this would, and so you're going to argue that eventually this approaches the size of a Planck length. Am I?
No, I forgot to tell you.
Is that right?
Yeah, I forgot to tell you. I retracted the Planck size. I don't need Planck size. I just need a black hole starts from a neutron, from a single neutron. For now, I don't. I retract the Planck size. We're just gonna. It's just a neutron. The neutron, it will become the black hole. We're gonna turn the neutron into a black hole.
Okay. However, I don't think I could be wrong, but I don't think neutrons ever do become black holes.
Well,
Neutron stars ever become black holes. I think that a neutron star is what happens when a supernova fails to create a black hole.
no,
Is that? Do you disagree with that?
no. It happens all the time. It's called an S1 nova, an N1 nova, M1 nova, N1 nova. I mean, it's a standard candle supernova. I think that neutron stars are the candle by which we measure the expansion of the universe. That is the candle. It doesn't matter. Of course, if you take a neutron star and you dump more and more and more stuff on it, so this neutron at the center will become a black hole. I mean, you can read it on, I think on Wikipedia there's an entry, they discuss it. This is standard science. Nothing I'm saying here is non-standard science. But I'm just going through a slow process of creating a black hole that no one ever did on YouTube. I don't know why. The entry on Wikipedia discusses it. We can go there and read it.
Okay.
I mean, they discuss how
it's my understanding is there's the Cepheid variable stars, which are not neutron stars, but then there's also like a peak brightness neutron star that can be used in astronomy to measure like expansion of the universe, that sort of thing. But my understanding is that these things are static. Right? Like once you get to a peak quantity of neutrons, then it just doesn't get any brighter. But that they're not actually growing.
Let me Google this. Can a neutron star become a black hole? I thought this is like standard science. Let me see. According, this is Brave AI. Mass limit. Neutron stars have a maximum mass typically around 2-3 solar masses. Tolman, Oppenheimer, Volkoff, TOV limit. If the remnant star has a mass exceeding the TOV limit, 2.2 to 2.9 mass of the sun, I think the combination of degeneracy pressure and nuclear force is insufficient to support the neutron star, causing it to collapse into a black hole. So they say this is the TOV limit. I once looked into the entry in Wikipedia. So this is standard science. I mean, they agree that there is a maximum pressure that a neutron can sustain.
I think what you just read is what I was saying, is that a neutron star is what forms because a black hole didn't. So for instance, our sun will never become a black hole because it's not massive enough. And so after the supernova, the core of the star collapses in on itself because of the absence of the radiation pressure and the huge amount of gravitational pressure, but it doesn't condense enough in order to form a black hole. And so the protons beta decay or alpha decay into neutrons, and you get a neutron star at the end of that star's lifetime, but not a black hole. and that if a black hole is going to form, it's from a larger star that therefore doesn't form a neutron star.
So
Do you disagree with that?
Yeah, I mean, yeah, of course, a neutron star can become a black hole. So the third entry on Brave AI says merger scenario: the merger of two neutron stars can produce a hypermassive neutron star, which may collapse into a black hole if it exceeds the maximum mass limit.
Yes. I believe that was it was like 2017 or so was the gravitational wave discovery. Was a merger between two neutron stars that did form a black hole for those reasons.
Okay.
So I'll buy that a neutron star will become a black hole in a merger scenario. But I don't think that other than merging with another neutron star, or merging with another hypermassive body,
no, I don't want to merge.
That a neutron star could absorb enough matter from its surroundings.
No, I don't want to merge. I want to slowly turn this neutron star into a black hole by just breaking its limit. So I'm going to read from Wikipedia. Okay. I'm going to read from Wikipedia the Tolman-Oppenheimer-Volkoff limit, the TOV limit. So it is an upper bound to the mass of cold, non-rotating neutron stars, analogous to the Chandrasekhar limit for white dwarf stars that become themselves neutron stars. Stars more massive than the TOV limit collapse into a black hole. The original calculation in 1939, which neglected complications such as nuclear forces between neutrons, placed this limit at approximately 0.7 solar masses. Later, more refined analysis have resulted in larger values. Theoretical work in 1960 placed the limit at approximately, data from, history. I want to...
Yes. So I think we're on the same page, is that whether or not it's precisely measured, in theory, for a non-rotating neutron star, there is a limit below which it stays a neutron star, and if you add one more neutron, you've crossed that limit, and now it becomes a black hole.
Right. So I just want to do that very, very slowly. So I want to add that final neutron to the neutron star. So I want to break through this TOV limit and create a black hole with just adding one extra. Mm-hmm.
Also, just to, I think you know this because you explained it in the rest of your website, but that limit that they measured of less than one solar mass is the mass of what's left over after the supernova when the star explodes a large portion of its mass away from it, not becoming that neutron star.
I don't care so much. I didn't understand that, but
right.
I'm gonna skip that. It's not important. Look, I just want to burden this neutron until I get a black hole, and you tell me what you think.
Okay.
So on this neutron is basically the entire neutron star is standing on this neutron's head. This neutron is supporting the mass of the entire neutron star. This single neutron is supporting the entire mass of the entire neutron star.
I think that would make sense. And so therefore that neutron or that point becomes a black hole into which all of the rest of the mass falls into.
Not yet. Slowly.
Okay.
Not yet. So we're going to do that very, very slowly. So, so let's apply pressure from all directions. And we could view this as force. So we're doing force over distance, right? The distance is the radius, let's say, before and the radius after. So that is the distance. Force times distance is equal to work, and force times distance is equal to work, which is, it's defined as work, which is also defined as energy. Am I right? So we've just invested energy. We invested energy into this neutron. a lot of energy. A lot of energy has been packed into this neutron. And we keep adding more and more and more neutrons, increasing the force, increasing the pressure, therefore increasing the distance, and therefore increasing the energy of this neutron. This neutron is just a powerhouse of energy. If you take this neutron and you just remove the pressure, it's going to expand with an explosive power of, I don't know what, a supernova or something. This one neutron could explode as an entire supernova or something. I mean, something incredible. A single neutron. Would you agree?
Kind of. So energy being joules is defined as newtons times meters, or force times distance, work and energy being the same, like you said. However, the amount of the the pressure being exerted by gravity is being fought by the strong nuclear force, which doesn't act over long distances. So if you were to suddenly remove all of the neutrons, it doesn't explode.
1 second. Okay, forget about the explosion. I mean, there is a tremendous
Okay.
amount of energy invested in this one single neutron.
Okay, I'll agree with that.
All right, so the next step would be something that I'll just take for granted from Einstein as a first principle. E equals mc squared. This is the rest mass of an object. Trap house, what do they want? 1 second. I'm in Ask Yourself server. Debating black hole formation. Okay. So, what do you think about? Do you agree we can basically take this for granted? For granted? Can we take E equals mc squared for granted?
Yes.
So Einstein said that the rest energy is the mass times the speed of light squared for some reason, whatever. He proved it. So I'm gonna just assume it's right because everyone says it's right, so we'll just go with that.
Yeah, okay. I'll agree with that. We're sort of approaching my limits. I don't want to agree and say something is absolutely true if I don't know that it is, but I don't have a problem so far with what you've said.
Yeah, I mean, like I don't know that F equals ma. I think I can derive it and stuff like that, but let's assume. Okay, so assuming E equals mc squared, assuming Einstein saying E mc squared is given. Later we can come back and question it, but let's assume for now that E equals mc squared. I think
Right.
the implication of that is that since we invested energy in this neutron, we necessarily increased its mass.
Did you stop speaking, or did?
No. It's just sometimes the whiteboard collapses and you have to restart it. But
Your mic just changed a little bit. I can still hear you, but it's.
Wait, can you hear me? Can you understand?
Yeah. Sounds like you just switched mics.
Wait, my mic switched?
Yeah, I can still hear you, but it's quieter and lower quality.
Okay, let me check 1 second. Okay, do you know how to sing in Spanish?
No.
Oh,
I
wait.
couldn't even pretend to.
Okay, let me hear myself on my YouTube's channels. So give me a second. No, my audio sounds good. My audio is my
Oh, okay.
my same terrible self audio. It's as terrible as
It might be my audio. I can still hear you.
okay. So if we assume E equals mc squared, then since we invested energy in this neutron, an amazing amount of energy, therefore we've increased its mass. Do you agree with that? You don't have to agree.
Can you say that again?
Assuming EMC squared is correct, that means if you take a box and you somehow invest energy in a box, or even in a spring, and the gluons are springs basically. So if you invest energy in a spring, you're increasing its mass. So these gluons.
That doesn't sound correct to me, but I can't tell you why.
Then that okay.
Okay. I see what's going on.
I'm just assuming this is correct. I mean,
So this one right here, that's like the potential, right?
no, there's no
Emax.
potential.
Like that's potential energy.
It's just,
Pressure.
it's just
Oh,
energy.
pressure. Okay.
Anyway,
And then what is this this figure in the middle
no,
here?
don't do that. Yeah, Jensen likes.
Oh, my bad. How do I erase this?
Okay, so what we're going through is essentially
No.
if we assume that
No, Jensen
there is a
Jensen doesn't really want to.
Wait.
He just wants to ruin this discussion. He wants me to leave and go to his one of his servers. I think he.
No. I mean, like.
Okay,
I'm
whatever.
I'm trying to use the eraser tool, but like it's
stop.
using an emoji instead.
there's an undo button.
No, there's not. I cannot undo it.
It's like glitched out for me.
Maybe I can.
I'm not looking at the screen right now. Is Jensen just fucking around?
Yeah, he's just fucking around. Yeah, Jensen.
Well, hold on. Let me get the other tool. I got that.
Jensen.
Jensen, are you interested in figuring out what we're talking about?
No, he's not. No,
Yeah.
not.
I just need to figure out how to undo this like thing that I put on the screen.
He just needs to figure out how to ruin our lives. That's all. It's really very straightforward. Okay, Jensen. Let me finish up this discussion and then I'll come join you. Come on. I.
Okay. Yeah. Sure.
So can you please undo your stuff so we can finish this discussion?
No, I'm trying to. Okay,
no,
listen. I swear I'm trying to undo
no, you're
it.
not.
And it's like it keeps just spawning in more like wacky gifs, dude.
I see what's going on now.
No, like it just keeps spawning in those gifs, man.
Jensen, would you prefer to talk about something else?
No. No, we're not. We're gonna finish up. Jensen, stop. Come on, let me finish. Jensen, stop. Jensen,
well, I want to.
Come on.
I want to see what Jensen's trying to get at here.
Okay, yeah. I got you. Hold on.
Okay, I'm gonna leave. I'm not.
Oh, nice, you did it.
Jensen.
Wait, just hang on for a second. Jensen has made himself unignorable, so I'm trying to figure out what he's about here.
He's not about anything. Yeah. He just wants to ruin this discussion. He finds it.
Is that true, Jensen? Do you deny that?
No. I'm trying to erase what I like that purple
Jensen
line, but
is
it's
actually
spawning in gifs.
Wait, you know, Jensen is a vegan. He's one of yours.
I'm just trying to like make it like erase the line, but it keeps doing gifs.
Okay, whatever.
Instead.
Okay, Jensen, I'm going to mute you.
Jensen, were you part of the discussion yesterday with Unmute? You were, right? You were the other main guy who was arguing against me.
Yeah, hold on. I think I finally found the. Oh shit! No, that's a dog gif. Okay, well.
So don't give me don't put him on me. I'm not a vegan. He's not one of mine. He doesn't like me either.
Tysca, what do you want to do? Tysca, I gotta go. If I'm not gonna discuss this, then I'm busy. I gotta prepare tomorrow. Hopefully, I'm gonna go to a local university and run the Michelson-Morley experiment.
Okay. Here we go. We black it out now. Okay.
So you have some contentions with Einstein, it seems. Although it sounds like most of what you're talking about so far is pretty orthodox physics, or at least so far as I can tell.
Yeah.
Do you have major problems with quantum mechanics, which would apply here? Quantum mechanics,
Yeah.
special relativity, anything like that?
Yeah, I mean, slowly. I mean, this discussion is it's crawling, to screeching to slowing down to a screeching halt. But the next step would be to actually discuss what is gravity, and explain that gravity is, unlike what Einstein said, gravity is the flow of space. It's not the curvature of space. Space.
What? How would you describe the difference between those two, curvature versus flow?
Curvature makes no sense and flow makes sense. So Einstein's theory of general relativity, gravity, I mean his theory of gravity is nonsense. It's just nonsense.
Well, I have to disagree with that. It makes no sense. I mean, obviously, it's well accepted uh, in physics, astronomy, etc., that the curvature of space-time
I don't care.
makes sense, whether or not it's correct.
I don't care that it's that you claim that you say that it's well accepted is not an argument. Einstein.
No, it's not. It's not an argument that it's correct, but it's an argument that it does make sense.
No, that's not an argument. To tell me that the space is curved, I don't understand it. So to me, it's nonsense. I've heard many people on YouTube, with very fancy schmancy degrees and stuff, explain Einstein's special and general relativity, and it's complete nonsense. And so is quantum mechanics. But Einstein's relativity I mean, it's just not scientific, because scientific means it has to make sense. It has to be understandable. And Einstein's.
But I feel like all of your critiques, all of these critiques of relativity, or the curvature of space-time not making sense, could also be made of gravity being the flow of space as well. No.
Look.
Or in what way does your interpretation make more sense?
No.
I suppose is a better way to ask the question.
No, Einstein said in 1920, in his 1920 lecture, he said literally, space doesn't flow. Space is stationary. There's a direct quote in a lecture in 1920. No, he said space is curved. He also said he doesn't understand relativity. So, of course. So his Einstein never understood relativity. It's difficult for people to swallow this pill. He kept saying he doesn't understand relativity, and people keep quoting him explaining general relativity field equations that he said he doesn't understand. So it's useless. Like, of course, it's not.
Well, if you're using quotes from his 1920s lectures, then it makes sense that he would say it doesn't make sense, and then go on to formulate his theory of special relativity over the next 30 years.
I don't need his quotes. I'm just, it's funny. You're telling me people say, I don't care what people say. It's obviously, special relativity and general relativity are not scientific. They're nonsense. They're nonsensical. They're not theories.
Is your interpretation more scientific?
Yes, it's mechanical, of course. But you don't understand the flow of space. I go back to the ether. My interpretation is to go back to the ether, which Einstein also went back to. In his 1920 lecture, he went back to the ether. He said the space is the ether, but it doesn't flow. So I go back to the ether, but I say it does flow. Right now, it's flowing into the Earth at about 6 million meters per second, about 10% the speed of light. That's the flow of the ether into the Earth. And that's why the Michelson-Morley experiment never worked, because they always made sure that it's perfectly balanced. So they perfectly neutralized the effect of gravity. But the ether is gravity. So you need to hold the interferometer vertically to see the interference. Do you have any idea what I just said?
Um. Yeah, I followed that. But what do you mean by ether? And then I feel like I have some issues with we are currently traveling 10% the speed of light as well. That would violate the E equals mc squared, or at least present considerable problems.
No, E
But
equals mc squared has nothing to do with traveling at any speed. That's just the rest energy to mass conversion. That doesn't that
right, but that's that's at rest. But you can expand the equation. It has another few variables to explain uh, things in motion at relativistic speeds,
yeah,
which we would now need to analyze the surface of the Earth with.
I don't know. I don't know. I didn't look into relativistic mass. I started studying. I'm new to this field, so I just started looking into relativistic mass. But anyway, so for my calculation, I mean, so I don't need a calculation. So Einstein said space is curved, and that is gravity. His theory of gravity is space is curved. So why does the apple fall from the tree down towards the center of the earth? Einstein says because space is curved. I say that's nonsense. That makes no sense. That's the most nonsensical statement any human has ever made. Literally the most nonsensical statement ever made in all of humanity, in all of history. And to have the entire scientific industrial complex repeat like,
Well,
like a bunch of
I,
cultists
I,
that this makes sense.
I think part of
It's garbage.
what makes it. I think part of what makes it hard to interpret is that he's talking about curved into into a fourth perpendicular dimension to R3. So, for instance, you've seen the examples at like science centers or whatever
Don't care.
of like
I
if
don't
you take
care.
a big
I
table
don't
and you
care.
strap over top of it like a piece of spandex or whatever.
I don't care. I don't care. It doesn't make any sense. Tell me that the apple falls or the moon is attached to the earth because space is curved. That's nonsensical. That's garbage. And that is not what Einstein's equations, his field equations, don't say that. That's a misinterpretation. But these equations come from his intuition. His intuition was okay-ish. He actually had a good intuition, converted the intuition into good math, but did not understand the math. As he said, he never understood. He never understood relativity. He did not interpret the math correctly. He didn't even interpret his intuition correctly. He simply he was basically blind, stumbling in the dark, and leading the rest of the scientific community, the blind leading the blind faithfully. It's like the emperor's new clothes to the power of the
But
emperor's new clothes.
but his theories do give explanatory power. So
Yes.
you're right that the birth of general relativity did come from his intuition, but he formalized it into mathematical concepts and a general theory that explains quite a lot and has more predictive power than any conflicting explanation that we know of so far.
Yeah.
At least that's what's been generally agreed upon.
Yes, I agree.
And when you say it makes no sense, I'm giving you good faith here, but I could argue that you just don't understand it, and that's why it makes no sense.
That's the definition.
And
What was that? The definition of makes no sense is I don't understand. I don't need good or bad faith. The definition of makes no sense is I don't understand. That's all I'm saying.
Sure. But you're positing your own theory that supposedly makes more sense. But I suspect that it runs into conflicts with the predictions that special relativity makes.
No. I
that
resolve.
special relativity would solve for.
No, there are conflicts there are conflicts within special relativity that do get resolved using the ether. And general relativity makes sense that gravity is the ether, and I am being dragged into the earth right now because ether is flowing through me at about 6 million meters per second, and this interaction is what is dragging me into the earth. And the ether flows to the moon, and that is what is dragging the moon into the earth. The flow of the ether. That is, you could say that
But
is.
I suspect that what you're, I suspect that is begging the question, taking all of the complexities and just putting it off on explaining what is the ether, what is its behavior, how does it work, that sort of thing. Because, for instance, many of the complexities of gravity could be explained out of special relativity by saying it's just a force like electromagnetism, and it's carried by a particle like electromagnetism. But we know that not to be true through experimentation, and so must create some sort of theory that has explanatory power given those facts.
I'm lost. What are you trying to say?
So, you posit that the ether explains what special relativity doesn't. But I think that explaining the ether is an unsolvable task, basically. I think that that's where the complexity or the doesn't make sense is going to come from, is explaining what you mean by ether. What is its behavior? How does it work? And how does it predict behavior once defined?
So I can explain it to you, but let's jump to 1920, Einstein's lecture in Leiden, where he said that the ether is general relativity fabric, but it just doesn't move. I agree with. I didn't see it. I just noticed it after I came up with my theory. So he agrees with me, except for the flow of the ether, but he agrees with a lot of my ideas. He agrees with hindsight. I didn't know he said that before I started my research. So the ether solves all the problems. And tomorrow, hopefully, I'll run Michelson-Morley's experiment vertically and confirm the existence of the ether and its speed at 6 million meters per second. Look, I'm either
Okay, cool. That was going to be my next question.
right or I'm wrong. You know, it's one. It's. If I'm right, then we're gonna get a positive result for the Michelson-Morley experiment. Finally, after 100, this is from 1886. This is 100 and almost 50 years, 25. Yeah, 100 what?
Let me
25. Yeah, 150 years.
pull that up on Wikipedia. Michelson-Morley experiment. Oh, that's right. This is when they were trying to determine in what way the universe was moving by measuring the speed of light in multiple directions and its reflection. If we were moving in a direction, then that would one of the reflections would bounce back faster.
Basically, they wanted to measure the speed of the ether. They knew that the ether exists because they assumed the ether is the media for electromagnetic waves. That is the definition. That is the Maxwell's equations assume an ether. That is the permittivity and permeability of space. That is the ether. So they assume.
Okay, and so you posit that the ether does exist. The ether is moving, but if you measure it horizontally like they did, then you'll get a neutral result.
No.
But if you flip it vertically, then you'll get a different result.
You'll get an interference. I was going to sit down and do the calculation in order to predict the exact interference I would get when I conduct the experiment. But you know, I found you, so
Okay.
But I still have time.
And so
yeah, I'm going to sit down
and so you're going to try to formalize your hypothesis and then run the experiment yourself and determine the result.
Well, I just need an interferometer. So hopefully I'm gonna find something, an interferometer at one of the, at a local university where I'm traveling. So I spoke to some people. Tomorrow I'm gonna hop over to like a third year college physics lab and put my hands on an interferometer. Hopefully I'll be able to hold it vertically with respect to the Earth's surface, and we'll get the interference pattern that Michelson died believing that he should have gotten it, and he never understood, never gave it up. He never gave it up. He said, "Forget it. That's impossible. It cannot be a null result." So he thought that the ether flows through past Earth, like through its orbit or something, like it's wind from the sun or cosmic wind.
Right.
He never contemplated that it
Uh,
is the flow.
I mean, it's I suspect that you won't get the result that you're looking for, but this is absolutely, without a doubt, the scientific method. And so, and I believe that an interferometer can be made crudely. I'll see if I can come up with a method to build what they're.
I'll tell you exactly what you need. You just need a source of light. If you have a laser, that's fine, but you don't have to have a laser. They use a candle. I mean, you can use a candle. You need a candle.
Yeah, but you need to measure very, very, very quickly.
No, you don't. You don't. No. You calibrate. It's very easy to calibrate. So you take the candle, and
because you get a wave interference pattern, you don't need to.
That's the calibration. So you
see the light moving.
Exactly. So you place
okay.
You calibrate it by placing it horizontally and seeing that you're not getting interference pattern by moving the mirrors to the location that doesn't give you the interference pattern. Then you take it and you flip it vertically, and you will see, hopefully, an interference pattern. Then you measure the distance between the waves of the interference pattern, and you compare it to what I'll calculate you should expect. And hopefully it's going to come out to 6 million meters per second. And we'll confirm the ether and throw relativity to the garbage where it belongs.
Interesting.
Yeah. This is less than.
So you've got a hypothesis? I'll do some thinking. I'll see if I can maybe even make the experiment myself. I've got mirrors. I can break a mirror, get some chunks of it. I've got a candle.
So in order to create a half mirror, you just remove little bits of it, so half of the light beams go through and half of them get reflected. So go to the back of the mirror and just remove a little bit of the silver paper, of the aluminum, of the silver foil, right? Every mirror has like silver foil at the back. You just need to
I can just take a mirror, break it into chunks, and now I've got more than one mirror. I think at this point we don't really have a debatable disagreement. This is we've reached scientific bedrock here, where the experiment needs to be done to determine. And I wish the best of luck to you in this endeavor. And I'll do some thinking on it and see if I can be useful to you in performing this experiment. Although if like you said, if you're going to a physics lab, you'll probably have much better equipment than I could ever dream to help create.
You can build. If you can build it and test it, that'd be great.
Yeah, I'll see what I can do.
I did the calculation.
I do suspect. I suspect that this won't be something that Einstein overlooked, but I haven't done the experiment myself, so I can't say for sure.
He said the ether doesn't flow. He said the ether doesn't move. He never understood. He said he doesn't understand relativity. That's a quote. He kept saying there's multiple quotes. He's saying he doesn't understand relativity. People follow Einstein blindly, believing that he understood it. He kept saying, I don't understand it. And the modern scientific community of modern physics they keep believing that he did understand it. He kept telling them, "I don't understand it," and they keep saying, "No, he's a genius. He was not a genius. He was a dummy dum with pretty good intuition. Maybe he's a little smarter than a lot of people, but we know a guy. He got many things wrong. He never understood it. So stop quoting him. He's not a parameter in this equation." This is one of the saddest cases in history. The reason why physics has stand still for the past 100 years is because we had Einstein. People worship this dummy dum.
You could be right. And if the experiment confirms your hypothesis, then you would be right, and it would be a massive breakthrough. And my hypothesis would be, I suppose, the negation of your hypothesis. But again, without running the experiment, this is a scientific question that the scientific method can yield answers to. And again, I'm not disagreeing with you here. I'm not fighting with you here. I'm totally on board with your scientific inquiry here.
No, you don't understand the reason. You never went to the calculation why I came up with 6 million meters per second. You cannot disagree with it. You don't know my theory. So do you know why I came up with 6
Right.
million?
That's what I'm saying. My hypothesis is nothing more than a hypothesis.
No, but why do you say that? Why do you say that? Could you take me off speaker? I keep yelling and you don't hear me.
No, I'm listening to you. I'm saying that I don't have any substantive disagreement with your theory.
Wait. When I yell for you to stop, do you purposefully ignore me?
No.
So what? Wait, do you?
I don't think I'm ignoring you.
So do you hear me yelling? No.
Yes, but I think that you think that there's a disagreement here that I'm not hearing.
Oh no! Do me a favor. When I yell no, do me a favor. I'm straining my throat. I thought I'm on speaker. If you're hearing a person yelling stop, then stop. I mean that's normal courtesy. Like I stop every time you interrupt me. I stop every time, and you never stop. That's not courteous. Just be nice. Anyway, wait. Why do you disagree with my theory? Do you understand my theory?
That's what I'm saying. I don't disagree with your theory. My intuition tells me that if Einstein was substantially wrong, we would have known it. But that's nothing more than a speculation or a hypothesis. My hypothesis is that...
Stop. No. That's not science. Ad hominem. What do you call
That's what I'm saying.
You're referencing.
I don't have a conclusion.
No. But that's no. Hold on. So you are appealing to authority. That's not science. Science is talk to me from first principles. What's your opinion? I don't care about Einstein. I honestly don't care. I used to have a lot of.
That's what I'm saying. I don't have a conclusion on which to disagree with you here.
Do you agree?
Do
you agree or disagree with me, and why?
I mean, it's a scientific inquiry.
Well, do you agree?
So you have a hypothesis.
Okay.
You have a well-formed hypothesis here.
Do you agree or disagree with my theory?
No.
No, what? Do you agree or disagree? No. What do you mean no? Do you agree or disagree?
I mean, no, neither. My intuition tells me that
I don't know what
Einstein is correct.
No,
however,
stop.
That's not me asserting a thing.
I don't care about it. Your appeal to authority. That's not science. So how do you feel about my?
That's it's not science. That's where the no comes from. Do I agree or disagree with your theory? No, neither.
Do you understand?
I don't have a scientific analysis of your theory because the experiment hasn't been run.
No, this is not. This is before the experiment is done. First, you come up with a theory, then you come up with a prediction. I mean, for experiment prediction, then you run it. But you first come up with a theory. Do you understand my theory?
Uh, I don't know that that's necessarily. We might be using theory in different ways here.
What do you mean? Explanation.
I mean, my
explanation to gravity. Do you understand my explanation to gravity? Yes or no?
I think so. Generally, that the ether is flowing towards the center.
What's your explanation to gravity? How does the apple fall from the earth? To the earth. Did I say from the tree to the earth?
I mean, I can't propose here anything that's not just what I have read from before.
No, that's appeal to authority. So you
right.
heard,
so I don't have my own theory.
Okay, you heard my explanation. Did you understand my explanation?
I believe so.
And do you feel it's a good explanation or a bad explanation?
You heard me summarize what I think your explanation was. Do you agree with my summary that is what you had explained?
Hold on. I don't remember you summarizing my theory. So let me ask you. So you said you understand or don't understand my theory of gravity?
I mean, in general, I think I understand that your explanation is that the ether flows towards the center of the Earth. There's probably some nuance that I don't understand. But if this explanation was the case, then redoing this experiment vertically would demonstrate that you do get an interference pattern.
Stop. Okay. Do you understand why the apple fall from the tree? Yes or no?
I suppose it depends on what you mean by understand.
Okay, then you don't understand. Can you explain to me? Can you build a mechanical contraption that simulates and explains the gravity, how gravity works? Yes or no? 3 dimensions. So I'm going to have an apple. There's going to be an apple, a tree, and Earth. And you got to build some mechanical contraption to make the apple accelerate towards Earth. Can you do that mechanically? Can you do it? Yes or no?
So
yes or
if we imagine like a physics program, you can just accept that gravitational acceleration is 9.81, but that's merely just accepting an observation.
Yes or no? Just yes or no?
If you were to build an entire new Earth, then presumably it would fall in the same way.
Stop. When I talk, please stop. If you start a sentence with, if you're going to build a new Earth, I don't care about that. I tell you to stop. Please stop. Don't waste time. I need to go back to my drawing board and do calculations for tomorrow. So stop. So if I give you a tree, I give you a miniature tree, a miniature apple, and a miniature Earth. Can you build a mechanical contraption to make the apple accelerate towards the Earth? Yes or no? If I give you a moon and an Earth, can you build a mechanical contraption, a miniature moon, miniature Earth? Can you build a mechanical contraption to make the moon go around the Earth? Yes or no?
I suppose I could build a contraption.
Tell me about it.
But
how would you build it?
Depending on the results of the experiment.
Tell me the setup. Tell me the setup. Tell me about it.
Yeah. I mean, so
I'll build it.
Imagine if you have what do you call it? the thing that you put overhead babies where it like spins. You know what I'm talking about?
No. I'm gonna give you a miniature Earth and a miniature moon
So in
3D.
presumably they would
No,
both
you
fall
got
towards the real Earth.
no. The Earth, you're allowed to hold onto the Earth. You're not allowed to hold onto the moon. Nothing can touch the moon. The moon, nothing. Can you see anything touching the moon? No, nothing is touching the moon. Make the miniature moon go in an orbit around your miniature Earth. No strings attached. Can you do that without touching the moon? Can you make the moon orbit
Am I
the
allowed to
Earth?
do it in space
In
or on
space?
the International Space
No,
Station?
you gotta build a No, you cannot use the actual gravity. No, you gotta do it in the laboratory. You gotta build a mechanical contraption to actually. You gotta build whatever it is that gravity is. You gotta build a mechanical contraption, a model. You gotta build a real model that simulates it and explains it.
So in that case, you would have to be unfaithful to the representation, but you could model something that demonstrates gravitational attraction between two
I
objects,
don't
but doesn't
care.
explain
I don't care.
why
I
it's
know
there.
about that. I don't care about that. That's not how nothing is touching the moon. Nothing is touching the apple. How does the apple reach the earth? Nothing is touching it. It's not placed on some two-dimensional fabric. There's no two-dimensional fabric.
Uh,
Space is not two-dimensional. It's
I,
three-dimensional. Nothing is touching the
I
apple.
think you're asking, but I think you're asking two different questions here. Is can you demonstrate gravity versus can you explain gravity?
Whatever. Choose whichever. You got to do it without touching the apple. Build a model that simulates gravity without touching the apple. Make it accelerate towards the earth inside a laboratory. Or you can also explain. You can start by explaining. You can start by building the model. But you have to explain to me how the apple is suddenly goes towards the earth. No strings attached. As Newton said. Right? There seems to be a vacuum between the two. Why is the apple attracted to the earth? Can you explain that? Einstein supposedly explained it to you. Why aren't you able to explain it to me? If only I don't understand Einstein, and apparently everybody does, then why don't you explain it to me? Einstein explained it to the world.
I don't think that wasn't my claim. Because obviously
So you
the
agree?
relativity is not understood by everyone,
Okay, then you don't look.
or even most
No,
people.
then you agree relativity is a nonsensical theory of gravity. If you don't understand it, you have to agree it's nonsensical. All he said is the curvature of space-time, whatever that means. I don't know what that means. I don't care. It makes no sense. It says 0.
So the experiment. So Einstein posits that mass curves space time, and so in a laboratory setting, you could take two masses, suspend them.
I don't know what that means. If you know,
but you could
then build a
suspend
model.
two masses, and if they deflect
Look,
towards each other
I'm losing
in
my
any
throat.
measurable way,
Okay, I'm losing my throat because this is too much. This is too much. All right, look, you can do it. You don't have a hypothesis. You're not objecting to anything I'm saying. You could either say you don't understand me, or you agree with me, or you disagree. So either you don't understand my theory, or you understand and you agree, or you understand and you disagree. I only see three options. Which is it?
could I not say that I don't know?
No.
That my hypothesis for the
you can't.
experiment
No,
can be
there's no.
something.
Stop saying hypothesis. Either you understand my explanation or you don't understand. And if you understand it, then either you agree or you disagree. There's no other option. I don't know why you're avoiding. Look, I'm tired. Okay, whatever. You do whatever you want. I don't have time for this nonsense. This is worse than the
I fully appreciate your desire to run the experiment. I'll do some research of my own and get back to you if I can find anything interesting on how to run the experiment. And I look forward to the results of that experiment. And if you would
Why?
like
Why?
my assistance
Why?
in running that experiment,
Why do you care about this experiment? It makes no sense. You make no sense. You are nonsense. Why?
because you have an interesting
Why do you care?
you have an
Explain to
interesting
me, why do you
hypothesis.
care? Explain why you care. Explain why you care. I don't understand why you care. This is so bizarre.
I don't understand what's confusing about that. I think
Okay.
that you have an interesting novel hypothesis,
What do you mean? Okay,
an
hold
experiment
on. Stop.
to demonstrate it.
What is my novel hypothesis? Do you understand it, or yes or no?
Yes, that
Can you-
that the ether is flowing.
What is causing the apple to be attracted to the earth according to my theory? Can you explain that?
The flowing of the ether,
What about it? How does that affect the apple?
or that space is flowing
Okay.
into the earth, and so
Okay.
the apple is stationary and the earth is moving into the apple.
No. You
Is
don't.
that
No. Then why don't you just ask me questions? If you don't understand my theory, just ask me questions. I'm in front of you right now. I can explain anything. Why is it so difficult to talk to you? Just ask me questions. If you don't understand my theory, just tell me. You don't understand, let me explain it to you again and again until you understand it. It's very straightforward.
I feel like we might be talking past each other.
Why
Yeah.
does the apple, according to my theory, why does the apple accelerate towards the ground?
So I thought I knew. I suppose I don't understand.
Repeat the story. Why does the apple accelerate towards the ground?
So my understanding is that the Michelson-Morley experiment, which you brought up, was trying to measure.
No. The Michelson-Morley experiment is because I have a theory. Based on the theory, I come up with an experiment and make a prediction. That's the last step. The first step is the theory.
Right. Well, I'm working in chronological order. But
No.
I mean, yeah, you're right.
No.
But my understanding.
No, please
my
stop.
understanding.
Please stop. Why does the apple accelerate towards the ground? Why? I'm losing my throat. Do me a favor, please. Either ask me questions. Ask me questions if you don't understand.
Am I incorrect in assuming that that your theory posits an ether?
Yes.
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 That is flowing. Yes.
Yes.
And because of this ether, it explains gravitational attraction. Yes.
Where is it flowing? What's the direction?
Towards the center of the Earth.
Okay, that's good. Go on.
Or towards large bodies of mass.
Or
perhaps.
Small. I was about to discuss the neutron as a massive object and explain that it has gravity, but fine. It doesn't matter. Anything with mass, yeah.
Right. That's what I figured. Since we started talking about neutron stars.
Yes.
My understanding is that your theory posits that there is an ether that is flowing towards bodies with mass. And that explains.
It flows into bodies. Massive bodies.
Yes.
It flows into massive bodies, yeah.
And therefore, and I might have gotten the mechanic wrong, but therefore, it explains gravity. My illustration, I suppose, would be that if you consider the Earth as stationary, then the ether is flowing into the Earth. But if you consider the ether stationary, then the Earth is flowing out into the ether.
No. The ether is flowing from all directions into the center of the Earth. If the Earth is moving into the ether, then
Right.
then the Michelson-Morley experiment would have not been a null result. The ether flows from all directions into the center of the Earth.
Right. I think that's what I said. I think that, I mean, if one thing is moving relative to another,
Why does the apple fall and accelerate towards the ground?
my understanding of your explanation is that the apple is being affected by the ether flowing into the Earth,
Good.
but the Earth is stationary relative to so the apple is stationary relative to the ether, which is being pushed
What?
into the Earth.
Hold on. Stop with. Don't use relative anymore. There's nothing relative in this discussion. Everything is absolute. The Earth is sucking the ether. The ether is a liquid that the Earth is sucking into it. The ether flows,
And therefore that motion is pushing the apple towards the Earth.
well, it's flowing through the apple. And the interaction, this might be the very Higgs interaction, but this interaction,
Sure. Okay.
this interaction,
and I may.
this interaction, yeah, drags the apple and is dragging me right now into the Earth. That is why I feel a force equal and opposite to the force that the chair is applying upwards. Where is that force coming from? Why am I feeling pain in my tushy? Because I'm being dragged towards the center of the Earth by the flow of the ether through me.
Sure. And you have a theory, an explanation, and an experiment. And I can be neutral, right? I can say that you have the experiment to lead. I'm interested in the result, but I don't necessarily have to agree or disagree with your theory.
You have to. If you look scientifically, either you believe me or you believe Einstein. If you believe Einstein, then explain to me Einstein. If you don't, then you believe me or you believe somebody else, since there is no alternative theory of gravity. Einstein is the only theory of gravity that I know of, and it makes no sense. And thank God I am here, so we can throw Einstein finally to the garbage where he belongs, and I can explain properly how gravity works. Finally, after thousands of years, humanity can finally know how gravity works. We stopped searching for the explanation of gravity because this idiot Einstein confused everyone and pretended to understand it. So finally,
am I not allowed to say that it is widely accepted that Einstein was correct? You have an experiment that may disprove Einstein, and therefore, if that is the case,
Einstein makes no sense. He cannot be correct. His theory is nonsensical. It cannot be correct. You cannot even you cannot use it as an explanation to explain why the apple accelerates towards the ground. So that's nothing. It's not an explanation. It cannot be correct. If it makes no sense, it cannot be correct. It's not scientific. It's nothing. It's garbage. It's literal garbage.
So maybe you're right.
No. What do you mean,
I don't know.
What do you mean maybe? What don't you know? Ask me questions. What is there left to know? What don't you know? How can you say you don't know?
Whether the prediction is what we see in the experiment.
So the question is, so this ether has nothing to do with gravity. Not Maxwell. So Michelson's experiment is about light. How is this relevant to gravity?
That if the experiment yields what you predict that it will, that the ether is flowing, then
how is
your theory of gravity?
How is it relevant to light?
that the ether would affect light and also
Why? Why would it
describe
affect-
gravity.
Why? Why would it do both?
Presumably, it would affect. Actually, I'm not sure I could explain why that would be.
Okay, good.
Can you explain why that would be?
Of course. So we just explained gravity, and we use the ether. We don't have to use the ether. We can use the fabric of space, as Einstein called the fabric of space-time. Garbage. But fine, you can call it. We can call it any name you want. You can call it space. Space is flowing. You could do that too. But if it's flowing and it's grabbing the moon, then it's a very rigid liquid. That means this liquid is surrounding us right now. Then the question is, why are we not feeling it? How could we be moving through this liquid? What is going on? What kind of a liquid is this? Why aren't we heating up? This liquid is, if we do the calculation according to Einstein and Newton's field equations, this liquid is flowing through us at 6 million meters per second. We're supposed to burn up. That's like 10% the speed of light. That's already relativistic. We're supposed to be incinerated by it. The planet, everything's supposed to. There's so much energy in that. That's ridiculous, ludicrous. But how?
Do you think we still have a disagreement?
What?
Do you think that we still have a disagreement, me and you?
About what? What are you talking about? What do you mean?
So, my view is that you posited a theory that could be correct, and that the experiment will determine.
But the experiment
Determine whether
we're doing Michelson experiment about interference of light. How is light relevant to gravity?
Because according to Einstein's explanation of gravity, the result that you predict would not be the one that we see.
Okay, I don't.
And so therefore,
stop saying Einstein. Stop saying Einstein. Stop saying. I don't care about Einstein. He's garbage. I honestly.
well, that's
useless. No. He's useless. I don't know what he said. I don't know what he said. You don't know what he said. I gave you the chance to explain gravity using this dumb curvature of space. You couldn't. It's meaningless. It's garbage. Let it go. We already agreed we cannot understand Einstein. So it's garbage. Let it go. It's useless in this discussion.
Sure.
Again. So so why are you mentioning Michelson-Morley experiment for tomorrow that we just discussed gravity, and you're confusing it with the ether? Why are you confusing the ether with the flow of the space that creates gravity?
Isn't the ether, under your theory, isn't the ether what explains
stop saying that.
the force of gravity?
No, but how is? No, we didn't get you. I didn't explain that yet. So I need to prove it to you. You don't believe me. I'm not a dummy dumb like Einstein that I'm going to say nonsense and everybody's going to believe me. I'd rather die.
I'm not saying that I believe that it is true. I'm saying that I believe that it is sensible. It is.
Why is it sensible? Why is the ether why is the flow of whatever creates gravity? Why is that also the ether that light flows through it? Why is that sensible?
That your explanation does could possibly explain the force of gravity, and it is heterodox to the accepted body of physical work, whatever. And so therefore, and that the experiment would contradict the modern understanding of what the experiment should yield.
I lost you. Stop. Please stop. I lost you. Look. Okay, so I don't understand why you think right now that the ether has anything to do with gravity before I show you the connection. So I didn't explain the connection. So you have to say they have to
Didn't
be
you?
separate. Do you see a connection or do you not see a connection between the ether and gravity? Do you see a connection?
Isn't didn't you explain that it's a liquid, a rigid liquid that is forcing us all down? You also mentioned that we should be moving quite fast through it, and it should heat us up. I'm assuming that you have an explanation to that I don't know. But nonetheless, if that were true, if there was an ether that's flowing into the Earth, then presumably it would take everything on the Earth with it and explain the force of gravity.
But how is that the ether?
And I can
How is that relevant to light? Why would light be influenced by
and
this liquid?
uh, I I'm assuming that the ether and space, the medium through which the light travels, are fairly synonymous in ways that I don't fully grasp.
Okay,
But
okay,
nonetheless,
then
I do
okay.
grasp
No, no,
that.
no, no. Stop, stop. Either you fully grasp or you don't understand. So don't confuse light and the ether with gravity unless you understand that there's no way to disconnect them. That I was forced to connect the ether with gravity. I tried to disconnect, I couldn't. So you need to be at the same situation. You need to understand that the ether is gravity. There is no way to separate them. You need to be able to prove it 100%, no less. There's no way around it. Do you want to ask me questions?
Um, I kind of feel like we're talking past each other a lot, but I'm interested in the experiment. I think that there's,
How
and
is
I'm agnostic.
How is Michelson's ether experiment that has to do with light? How is that impacted by a theory of flow of space for gravity? Why are these two things relevant to each other?
I suppose I don't fully know,
No, what do you mean fully?
but I just
No,
accept it.
no.
I,
Stop saying fully. Stop lying. Either you understand or you don't.
okay, I
No,
suppose I
fully.
don't know.
Okay, good. Then ask me. You want to ask me the connection?
Would you like assistance on the experiment? Would you like me to try to see if I could replicate it with a broken mirror? And
No, no. I want you to understand it more than I want you to run the experiment. It would be nice, but I want you to understand it. Don't run to run the experiment when you don't understand that it should work or not. You're not curious that it should work or not? You're not curious? Like you just believe me that it should work?
um, sure. Isn't that what most grad students working in physics labs do? They just assume that
No,
experiment that they're working
I
on
don't
is
care.
supposed to yield a certain result or whatever.
Aren't you curious? Aren't you curious to see that the ether is gravity? Don't you want to hear the proof? Yes or
Um,
just yes or no? Are you curious to hear the proof? Yes or no?
sure, I suppose so. But you were saying that you were out of time or
No,
wanted to get to other things.
no, this is too important.
Um, well, I am limited on time at the moment.
Okay.
Would you like to schedule another talk for tomorrow, and then we can go over the proofs of the theory and talk more about it?
I'll just give you the short version, like the elevator page. So this liquid, it has to be really rigid that it and basically you cannot move through. If you move through it, you burn up. So you cannot move through it, but rather you can wave through it. That you have no problem waving through this material. So we are just waves. Our bodies are waves through the ether. We are ethereal. We're literally ether. We're just waves of ether. Just like there is no wave of water. The wave is water. The wave is the ocean. We are ether. The table is ether. The bricks are ether. The air is ether. We're waves in ether. And as waves, there's no problem. We can wave at the speed of light, because that's the speed of
Yeah,
propagation.
I'm curious why you used bricks as an example. Did you remember that I'm laying bricks right now?
Of course. I can see the bricks in front of my eyes. I can still see them. So
You are an ether bender.
these bricks are particles of light. There is no particles of light. They're waves of light, but they're bouncing back and forth
Okay.
because of the Higgs mechanism that gives them the apparent mass. But the Higgs field is the ether. So everything.
Have you written this down more thoroughly anywhere
Yeah,
other than your website? Because that's all I've seen of your writing.
I started writing a paper. It's all on video. Everything was developed on video in real time. Everything was recorded. This is it's just 1 week. A week ago, I didn't know any of this. It's so simple. I can't. I just one day, like a week ago, after a debate with some guy, he kept quoting nonsense quantum mechanics. I said, enough is enough. I gotta figure this out. I woke up the next day, I started researching, and in 1 week, everything makes sense. Special relativity finally makes sense. General relativity finally makes sense. And quantum mechanics finally makes sense. Everything makes sense all together under one field, the unified field. I have a unified field theory. That is ether. Ether is the unified field theory. It was staring us at the face
Okay.
150 years ago, after the Civil War. Michelson knew the truth. Einstein is garbage. Einstein delayed the history of science by 100 years, if not more. I wouldn't blame him. I blame the people that the scientific community that worships him for no reason. So anyway,
Do you think that I should? Do you think that I should read up on Michelson?
there's nothing to read up. I mean, the experiment is very straightforward. But okay, so the explanation is that there's no way we can survive interaction with the ether as particles. That's why there are no particles. That's quantum mechanics. Everything is a wave. That's the particle wave duality. Everything is a wave. Everything is waving. When you interact with it, it looks like a particle, but that's an instantaneous interaction. When you don't interact with it, it's a wave because it's always a wave. It moves as a wave. That's why through the two slits you get an interference pattern, because it's a wave. It's never been anything else. Because particles cannot live in the ether. It's too harsh. Everything can only survive as a wave of ether.
Okay. Would you like to? I think we've been going for 2 hours now. Do you want to do another 2 hours tomorrow at the same time?
Sure.
And we can go through more in depth.
Sure. Thank you.
Cool.
I appreciate your time. I'm sorry I was yelling, but it was. I mean, I get upset when I have to explain myself. I'm sorry.
You're good.
Yeah, you're good.
Also, you seem to. I guess. Oh, who was the other guy that was in here that was drawing?
Jensen. He's my friend.
Benson. I guess you've talked to Benson before.
Yeah, he on the first day on Discord after I debated Dr. Avi and mopped the floor with his face. Jensen took me all over Discord and introduced me to everyone.
Interesting.
Yeah.
Yeah, I'm not super familiar with him. I'm not super familiar with this Discord either. I'm not entirely sure. I remember exactly how I got here in the first place, but they've got lots of strong opinions, some of which I disagree with, and I find it fun to listen to them.
You can come to my server like during a lot of hours during the day that I'm doing research. I'm in the general VC as I'm streaming on YouTube and doing research.
Okay, send me a link.
Okay, I'll send you a link. All right, man. I'll let you go. I really appreciate your time. I'm really happy that we got through this, and it's all recorded for for everyone. All right, man.
Cool.
Yeah, cool.
Yeah,
See you tomorrow, man.
for sure.
All
Have
right.
a good one.
Yeah, you too. Bye.
Bye bye.
All right. That was good. Good stuff. Good stuff. Oops. Oopsie daisy. All right. So. Very good. Very good. We got through a lot of stuff. A lot of good stuff. One person. Let's read some comments. Leslie Moore says, you can't expect him to come up with a mode so quick. A mode? Leslie Moore says, maybe the ether is in liquid form, but of a different density that we cannot feel, but has incredible strength or pull. Is that possible? Did Einstein mention the ether denseness? No, he just mentioned that he believes it is the general relativity fabric. You can. I have lectures. I read it. You can look it up in one of my previous talks on YouTube. You can find it. But you can also look it up. 1920 Einstein lecture in Leiden, Leidn or something. Just the final paragraph. It's really straightforward. I don't want to look it up again. I'm tired. So you can read it. You'll see that everything I said, he said. But you can see that I only found it after I came up with all my theories, after I gave up on Einstein, and then I realized I'm too harsh on Einstein, obviously. I mean, he didn't know what I know. Like, I'm standing on his shoulder, so it's really not nice that I'm mistreating him. So we need to respect everyone. Or I don't want to be too harsh on everybody. Everybody did a lot of hard work, but we need to put everybody in their proper size. So Einstein needs to, we need to shrink Einstein to his human size. People have grown Einstein beyond proportions, and we're worshiping the scientific community. We need to stop doing that. Everybody is doing good work, but we're we need to remember that everybody's a human. Everybody's prone to all sorts of nonsense, including me. So you gotta don't believe me. Like like what's his name that I was just talking to. So he wanted to believe me. I said, no, don't believe me. If I don't want you to believe me, I want you to question me. I have proofs for everything, or you can find errors in my proofs. I'll be appreciative for that. I want the truth. The last thing I want is accolades for no reason. I'm not interested in that. I'm not here for that. I'm here to, if I can, to help humanity. That's it. I'm just here for everyone. I'm here like we're all in this together. This should improve our lives. Like this should send us to the stratosphere. So, and I hope to make a little bit out of it extra. But this should send humanity into the stratosphere because finally everything we're gonna have all like physics and modern physics is finally going to make sense, and science is going to make sense. No more of this garbage Einstein nonsense magical thinking, completely incomprehensible relativities in a vacuum. Nothing makes sense. I mean, nothing makes sense. And this was bothering me a little bit every time I studied a little bit of relativity. I went just a little bit bonkers trying to understand what the heck is going on. How could this work? Special relativity never worked. General is utter nonsense, but the math is making good predictions. So something is right and something is wrong. So yeah, the math is somewhat correct. Time dilation is correct, but that's not even Einstein. That's actually Lorentz. Length contraction is not real. That's just an optical illusion. Mass, relativistic mass, I still don't know. As far as I understand, it's just It comes out of momentum. So I don't have an opinion yet. E equals mc squared. I don't have an opinion about that yet. The general relativity equations seem to be okay, but the interpretation is is horseshit. It's not curvature. The geometry that Einstein had to learn to develop general relativity is called curved geometry. You can't tell me that the conclusion of his theory is the name of the math that he used to develop his theory. That doesn't make any sense. That's nonsensical by itself. Of course, it's not curved. You could say that the curvature is the acceleration of the ether. Maybe that's what he meant. I think that's what he meant. That's what he would have meant if I would have been there to ask him. Is that what you mean? If he would have denied it, then fine. Then he belongs in the garbage. I don't care. Look, I don't want to judge him. Anyway, let's go. So maybe the ether is saying maybe ether is in liquid form, yeah, but of a different density. But we cannot feel. Well, we cannot feel it because we are it. You cannot feel it because you are. That's like you are it. Everything around you is it. You are ether. Of course, you cannot feel it. You are it. How can you feel it if you are it? Can you feel you? No, you cannot feel you. You're waving through the ether. You're a wave in ether. You're a quantum mechanical wave in ether. That's nothing but a wave. You're just a wave through ether. There's nothing complicated about that. That's it that we cannot feel but has incredible strength or pull. Well, there's no well yeah, there is the pull. I mean, so the ether flows into massive particles. And when there's a bunch of particles like the earth, so there's a lot of ether being dragged into all these particles. So you're getting massive, like a massive vacuum cleaner. It's like a massive pump. So you can look at the earth or any massive particle as a sink, as a gravitational sink, as an ether sink that's dragging in this liquid, and it's creating a vacuum, and that vacuum pulls in more and more and more of this liquid. Now, this liquid is running out. The universe is running out of this liquid, but apparently it's getting replenished simultaneously in the intercluster space. That's where we seem to have dark energy that seems to be just a replenishing of this ether. Ether is just being created there. Is that possible? Well, what I explained is just what's my explanation. Did Einstein mention the ether's denseness? No, I think he mentioned that it has to be stiff. Everyone agrees it has to be stiff. Everyone used to agree that it would have had to be stiff in order for the speed of light to be 300 million meters per second. It's just got to be really stiff. Because we know that the speed of sound in air is 300 meters per second, and the air is kind of stiff. So imagine something 1,000 times faster, right? 300 meters, 300 million, a million times faster. So it's a million times stiffer, let's say. I don't know. No. Uh, all I have is like one paragraph from Einstein. You can look it up and read it. It's readable. The ether has, no, it is rigid liquid. It is a rigid liquid. So is Einstein saying the ether is responsible? Yes. 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 He definitely says that. He says the ether is gravity. I gotta watch this from beginning. Yeah, you might do yourself a favor. Mr. Awesome Top Guy says, "Yo, let me get in there." Oh, I didn't put the link. Shite. Shite. So Leslie Moore says, "Don't you think it's a bit grandiose if you, I guess, of you to suppose that with 1 week of studying that you can disprove Einstein?" I didn't wake up a week ago with the thought of trying to of disproving Einstein. I assumed what everyone tells me, that Einstein is this god, this super genius. Rick from Rick and Morty is modeled after Einstein, and so is Doc Brown. And these are super duper geniuses. But Einstein seems to be nothing of the sort. He was a complete nincompoop. He was just a buffoon. He didn't understand his own equations. What? How is that? How can he be so dumb? That's like being a. That's what his teachers kept saying. He was just a lazy dog. I'm also lazy, but I don't pretend. Maybe I do pretend. Look. Let's not judge him. I don't know what to tell you. Like I don't. I didn't wake up planning to disprove Einstein. I'm not interested in disproving Einstein. Disproving Einstein at this point is just what I have no choice. I'm forced with my back to the wall to disprove Einstein. It's not disproving, it's proving that he's an idiot. That he destroyed all of modern science. So humanity has been, this was basically a dark age. This 100 years since Einstein has been a very dark age. And he's guilty. It's his fault. He did it. Michelson, if we didn't have Einstein, Michelson would have continued, and everybody would have continued to think about it. But Einstein threw everything off. I don't know why they followed him. I don't know. I don't know why they read his why Planck. Planck is guilty. Planck read his paper and Planck said, "Genius, bring him before me." Why would you say that? Everybody laughed at Einstein. Everybody said this guy is a joke. But Planck said, "No, he's a genius. Bring him before me." And that's it. And since then, we have Einstein. Look, he came up with general relativity field equations. They seem to be very good. It's based on, his intuition of the equivalence principle, which, is kind of interesting. I mean, yeah, he gave us general relativity field equations, but he confused us with the interpretation. And he claimed that there is no ether. I mean, anyway, look, he's not perfect. I don't know who to blame. I don't know who to blame. We are to blame. I am to blame. I took my time. I should have taken care of this many years ago, but I just assumed what everybody assumes. I had to go through this process myself. Like, I had to learn what is science. Like, I've been learning my whole life what is science, and I only recently came up with Proposition 90. What is science? Science is understandable. If it's not understandable, it's not science. Once I realized that, that's it. It was trivial to realize Einstein is not scientific. And we don't have science today. Based on that, we don't have science. Once I realized, okay, we don't have science, so okay, everything flew so fast once I realized what is science and what is not. And that took me many years, so I don't know. Anyway, maybe I just got lucky. I don't care. I don't know. It's whatever. I didn't plan. So don't you think it's a bit grandiose? No. Einstein dethroned Newton. So everyone said, like, how dare you? Newton was the greatest, was a god. How can you dethrone God? So Einstein was a dummy dum dum and he dethroned Newton. Newton was okay. I didn't see any problems with Newton. Newton could have stayed in physics. Instead, he went to the mint and worked in finance. If he would have stayed in physics, he probably would have figured out general relativity. Maybe. He would have come up with a theory of gravity. Maybe. The speed of light, they didn't know about that. I don't know. I don't know. So don't you think it's a bit grandiose? I didn't plan to look. I'm forced with my back to the wall to say Einstein is one of the worst things that happened to humanity. Right? He did some good things, but it's also one of the worst things that happened to humanity, because he introduced this anti-scientific science, this garbage science to humanity, and this destroyed the scientific industrial complex. It gave us this corrupt scientific industrial complex that is 99, I don't know how percent wise, but it's full of BS. I blame Einstein and Planck for discovering Einstein, quote unquote. So don't you think it's a bit grandiose? Yeah, because people have turned Einstein into a god, and no one is a god. I'm not a god. I am the first to admit I'm the ultimate dummy dum dum. I like when I watch videos, I only know physics from YouTube, from very few videos. Just that when I watch a video, if I don't understand, I skip it. Either I understand it or I just skip it and skip and skip. But sometimes you find videos and you say, "Wow, finally I understand this. Finally I understand that." So I'm the first to admit I'm a dummy dum dum, and I just got lucky. And I had, I started debating helped me figure out a lot of things. Right away I realized that debate, you can read in my website that debating is the most important thing in order to reach the truth. There's nothing like debating. I never knew this. And then once I realized that, I knew I need to start really debating around the clock. And the more I debated, the fastest I made progress. In general, realizing how, life and everything. You can follow the propositions. Anyway, so don't you think it's a bit grandiose of you to suppose that with 1 week of studying that you can disprove Einstein? It's what it is. What do you want me to do? What? Within 1 week, I figured everything out. It's everything. That's what you expect. You expect, the truth to be simple. You expect the answer, the true answer of the universe to be simple. And that's why nobody could figure it out. You could argue that. It's too simple. It's too simple. People, for some reason, they overlook the obvious. That's like, that's common. It's a common saying. People overlook the obvious. So it's too simple for many people. It wasn't simple for me in the beginning. In the beginning, it was complicated. I couldn't figure it out, but the main, there were many, many breakthroughs. You can see in my videos, but one of the main breakthroughs was when I developed the Newtonian gravitational field, vector field equation for the velocity. From the acceleration, you can see the velocity. And once you can see the velocity, then you understand, oh, then space is flowing at different rates. This acceleration of test particles, of almost massless test particles, oh, then that's the acceleration of space. Oh, that's a black hole. So the equation that gives you the black hole, I could convert it to the equation that gives me the speed of flow of space right here on the surface of Earth. And I did that in one of the videos. So everything became so simple. It's like what you hear the physicists and the mathematicians talk about. I don't know what they're talking about. I still listen to them. I have no idea what they're saying. I don't know if what they're saying is good or bad. I don't know. I don't know what they're saying. But as far as I'm concerned, it's garbage. All of modern science, all of modern physics is utter garbage. I don't know. I don't know what they're doing. I don't know what they've been doing for 100+ years. The, they agree. They agree that they've been stuck for 100 years. So, yeah, I agree with them. Okay, last comment. Oh, you're still writing comments? So, don't you think scientists in wait? Let me give you the link. If you want to still discuss it, let me give you the link to my la 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 la. Ta-na-na-na. Let me give you the link. If you want to come over and discuss it, you may. You're asking good questions, less is more. The questions today are off the chart, good questions. So So don't you think other scientists in his field and other fields have tried to disprove Einstein? I didn't try anything. I just got sick of, okay, so I gotta work in 5 minutes or work out and gotta go. Yeah, it's fine. Yeah, you can come back anytime you want. Anyway, so don't you think other scientists in his field and other fields have tried to disprove Einstein? I never tried to disprove Einstein. I just tried to understand quantum physics. I just got tired of debating people that kept bringing up quantum physics as an excuse for why we don't understand any topic of debate. So everything is allowed. God is allowed. Ethics are allowed. Veganism is allowed. Everything is allowed. Freedom of choice is allowed. Indeterminacy is allowed. Things that are to me abhorrent. How can you believe in the indeterminacy of the universe? That's anti scientific. That I can't. That's ununderstand. I cannot understand it. So you believe in something I cannot understand. So if I cannot understand, you cannot understand. Steve. Oh, okay. Wait, what am I sharing? Oh, I'm sharing. Okay, okay. It's good. Hey, la, 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 la. Okay, don't you think other scientists in his field and other fields have tried to disprove Einstein? I don't think anyone tried to disprove Einstein. I don't think that's interesting. I don't care about Einstein. I never cared about Einstein. I cared about understanding reality. Einstein told us a story about reality. I wanted to understand it. Everybody kept telling me it's all been proven. We ran all these experiments. Everything is true. And now that I'm doing a deep dive, I realize no, that's not true. That's not true. It's all wrong. Nothing was proven. Everything I look into, no, it was never proven. No, it's all optical illusions. Nothing was proven. It's just wave mechanics. There's nothing. There is no theory of relativity. So don't you think other scientists in his field and other fields have tried to disprove Einstein? I don't know. I don't know. I don't think anyone wakes up in the morning wanting to disprove Einstein. That I got lucky, that everyone says as if that everyone is trying to disprove him, and I got lucky and I've been able to not just this. It's not about disprove. I mean, he is garbage. He's not a scientist. Einstein was never a scientist. As far as his theories, these are not theories. These are not scientific theories. It's worse than disproving. Disproving is, it would have been mild compared to what I'm doing to him. And this is just the beginning. But anyway, that was never my plan. I don't care about Einstein. I don't care about anyone. I care about all of us. I want to understand the truth. And the truth, I'm very curious about it, but also the truth is very useful. Once you know what is true, you know not to drink poison and you know to eat of the tree of life and knowledge. So that's good. And yet, you with 1 week of learning, because some guy you debated through quantum mechanics, yeah, yeah, you can watch this is all on video. You can see exactly when I took time out to start doing this research. This is basically a week ago. This is basically when I met my, maybe even not even a week ago. I don't remember. A week and a half, maybe 2 weeks. I don't know. I don't know how long, but it's nothing. It's zero time and zero investment. How much time do you think I invested? I didn't invest a week. I invested maybe an hour, two, three, four, five. I don't even think I came up to 5 hours. If not even every day. Maybe every day, but on average, maybe 2, 3 hours net. Most of the time, I was still doing nonsense. So very few hours to figure out that Einstein is an idiot and that the entire scientific community, that I already knew that the scientific community are a bunch of idiots because they believe in global warming and they believe in the schmendemic. They believe in all the nonsense we know is utter nonsense. So I already knew that the scientific community is garbage. But at least I hoped, they worship Einstein. Maybe it's reasonable to do that. But now I see even that is unreasonable. It's an unreasonable community. So, terrible. We have been very unlucky. And the fact that humanity made immense progress in this 100 years. I mean, imagine what kind of progress we would have made if not for this nonsense from Einstein, this anti-science. Anyway, made you learn and able to disprove Einstein. Yeah, that was never the plan. I never planned. I just wanted to make quantum mechanics make sense, but I had to. I don't even remember why I couldn't do quantum mechanics. I mean, after the debate about quantum mechanics, I started quickly looking into everything. I started learning, okay, what exactly is going on? What is the wave particle duality? What is the Heisenberg uncertainty? What is Schrodinger's wave function? What are these things? What is going on? What is the explanation to the double slit experiment? And I started looking into it. I already started looking into it a little bit before, but now I went full force. Now I said, okay, enough is enough. I gotta crack this. If no one has made any sense. Now I knew that Einstein hated quantum mechanics, and I did respect Einstein. So I assumed quantum mechanics is garbage. But as I started learning, I saw quantum mechanics is okay. But then but then I came up with my theory of gravity because nothing else, I don't even remember why I wanted to do that. But my theory of gravity left no room for for particles. You cannot have particles if we're filled with this liquid all around us flowing in at these speeds. There's no room for particles. Particles can't exist in this under these conditions. Particles can't move. Particles can't just have inertia. That's irrational. That's magical thinking. So okay, so everything must be wave. Oh, and then I said, oh, so everything is a wave. Oh, that's quantum mechanics. That's why we have the wave duality. Now I believe there is no particles. There cannot be particles. There's only waves. Things are only waving. Particle is what it looks like during the instantaneous interaction. It instantaneously looks like a wave. It looks like a particle. But there's only waves. And that is what quantum field theory says. It's all just waves. So fantastic. So everything works out. So my intuition is that the title of fields of modern physics. So everything is good. So everything falls into place. Last comment. You got to work out in 5 minutes. And you got to go. So, all right, all right. Okay, okay. All right. Thank you, everyone. I'm really happy that I'm having this all recorded. So it's good content. It's good to teach. Everyone should learn from this process. You can see that I'm not a genius, that it was like very fast. It's very fast to figure out these very simple concepts because I was just being I was being very simplistic. Why did this move? Something just moved here. Anyway, oh, okay. Have my $5 ready tomorrow, but okay. I don't know if I'm gonna run the experiment tomorrow. I'm planning to go to a lab. Hopefully, I'll run the experiment. If I get a null result, it's back to the drawing board. I might have to take everything back. But, who knows? I mean, it might be that the two arms of the interferometer do compensate for each other, even under the flow of the ether. But Michelson, I didn't do the calculations. I'm assuming that everyone did the calculations It's too much for me to do the geometrical calculations. I saw I saw a bunch of videos and they said, yeah, there should be a little bit of a difference. It should be a little bit slower in the direction of the flow. So that arm should be just a tiny bit slow. Perfect. So it should create an interference. So I should be able to see it. Now the flow is really fast. It might create the problem is that the flow might create an exact wavelength difference. If it creates an exact wavelength difference, we're still not going to see an interference. But if we rotate, then we should get somewhere in between. We should be able to get interference. So let me run the experiment. It sounds like it should create an interference, and I don't know about exactly what wavelengths to expect. Now these two beams are side by side. So side by side, or they should be aiming at the same spot. Now, I don't know what would happen. I mean, first we need to see that we get interference when one arm is short and one arm is long. We need to calibrate the device. We need to first we need to make sure that this is like test-driven development. So first you need to make sure it fails. Make sure the test fails properly. So first, two different lengths arms should give you an interference pattern. If that doesn't work, then we know the device should have never worked to begin with. So first we need to show an interference pattern. Let me see. Has anyone done this? How to calibrate? Okay, how to calibrate the interferometer, or an interferometer. How to calibrate an interferometer? You need to calibrate it. You need to see the wave interference. Use a point source. Observe a point source, such as a signal from a single isolated object with a known constant flux density. What are you talking about? What flux density? Polarization is a function of frequency. What are they talking about? Absolute sky zero. What? This is a typical calibration signal for the total observational response of an interferometer. I don't know what they're talking about. Back-to-back geometry. Range that. Has anyone ever run an experiment with an interferometer on YouTube? Maybe they were holding it vertically for a second, and maybe they got the interference pattern. They didn't notice it. Let's Ti la 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 la. La 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 la. Ti la la. Let's look it up. Ti la 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 la. Okay, so we need to do my Kelsen interferometer, not experiment, just interfere. Any video about it? There it is. You saw there. That's an interference pattern. When the two beams are aimed at the same spot, I'm talking about where my okay. That's an interference pattern. Let's maybe listen. It's a 4-minute video. The experimental setup. This is good. And this setup interferometer is used to measure the wavelength of laser light. Good. This is good. So perfect. That is perfect. Look at that. Beam splitter. So this is half mirror, adjustable mirror. Okay, this is a mirror. This is movable mirror. There's two movable. I don't get it. Using interferometer to measure wavelengths. But everybody's okay. And there it is. You see? Moving, and now he's going to calibrate. Moving the mirror. Let me see. Oh, come on. Okay, fine. Moving the mirror changes the positions at which the light constructively and destructively. Yeah, so good. So it should work. So we should see this. Now, if this guy would have just turned, well, first he needs to calibrate to see that he's getting one big spot. Each time the pattern returns to an identical position, the mirror has moved 1/2 wavelength. Yeah. So every time it returns to something, it looks the same. That means we're moving the mirror by 1/2 of a wavelength or something. But okay, the cycles will be counted. So as he's twisting this knob, he's moving backwards and forwards by a few millimeters, and he's counting cycles. So how many cycles per millimeter? Something like that. Okay. Interference fringes are marked so that cycles may be counted more easily. Oh my God. I don't know how to use this device. Oh my God. I'm not going to be able to figure it out. With the micrometer knob, that's the moving back and forth of the mirror. They move it by 1/1,000,000th of a meter. That's tiny. That's probably like, I don't know, probably a tenth or 1/100th of a millimeter, whatever, is moved by 1/2 wavelength. The fringes will complete one cycle, and a new fringe will appear between the tape. Between the tape? The what tape? So he's putting a piece of tape here. Now he's going to move the micrometer. La 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 la. There it is. Side by side. Good. And done. 1. Count the number 2, 3, 4, 5, 6, 7, 8, 9. You can do as many as you want. 10, 11, 12, 13, 14, 15, 16. But this is not calibration. He's going to count it, then compare it to the distance traveled, and he might come up with a wavelength per distance. So 6.5 microns, that's millionths of a meter, is equal to 2d over n. I don't know why. He's not explaining. Why is it 2d over n? The distance traveled divided by the number of waves that we counted. That's lambda. Because, okay, 2 is because it's a full wavelength. We counted half wavelengths. So 2 times the distance traveled divided by the number of cycles should give you lambda or something like that. I don't know, whatever. Let's trust this guy, okay? So 2 times 6.5 micrometers, that's what we traveled, divided by 20 cycles, or 20 whatever. So it's 0.65 nanometers. Red. Oh, yeah, 0.65 nanometers is red. That's red, the red color. Okay, but we need to calibrate it. How do we calibrate it? What did Michelson and Morley expect to see? Oh, so as you rotate the device, you expect the same count. That's exactly what you expect. Exactly. So as you rotate it, you expect to get a change in the interference. You always get an interference. So it's not everybody misstates the Michelson-Morley experiment because no one has conducted it. So you don't want to get an interference, but you want to see the change in interference as you rotate the device vertically. So sometimes it's towards the ground, sometimes it's forward, sometimes it's towards the sky, and so on. You rotate it, and as you rotate, you see the interference pattern changing. Yes, yes, no, no. That's not more complicated. It's this very device he could have used to prove Michelson and Morley correct. The theory behind the measurement. Well, we know the theory. I didn't think they're going to explain the theory. This is an interferometer. This is exactly what I need. So a lab should have this. Who is this? In this setup, interferometer is used to measure the wavelength when this is 12 years ago. Where the question is, where can I put my hands on this? So the question is, can I lift it? Or is this like this this looks like a person can lift it. So we need to be able to lift it and put it and rotate. The problem is that it sends the signal out. So I'm going to put a piece of tape here in order to see the signal here because I need to rotate and see the signal changing. This will be evidence that the ether is flowing. The question is, at such a high rate, hold on one second. La 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 le la 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 le la 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 ti la la. La, 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 la. Yeah, I gotta answer some messages. Yeah, but my chick hates me. My chick doesn't want me anymore. I'm looking for a chick. If a chick is interested in a guy like me, please come into my life, please. La 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 la. Anyway, so this is an interferometer. The problem is that the signal, the beam goes over there to the wall. We don't want that because we want to be able to rotate and see the signal changing as we rotate. The question is, what do we expect, right? So the difference between, so what happens? Okay, let's talk about what happens. So where is the signal coming from? I guess, oh my God, the signal is coming from here. There's a laser. So this device, it's not a complete interferometer. This is only part of it. So, one second. La, 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 la. I'm getting messages from everyone, just not from love of my life. Love of my life. La, la, la. La, 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 la. Wait, I have messages. La, 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 la. La, la, la. Don't take it away from me because you. Oh. La 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 la. La 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 la. What it means to me, I miss you. Once second, I gotta send a message. 1 second. Okay. Back to reality. Oops, there goes gravity. Oops. Okay. So yeah, this is not a good model. This is useless because the laser, the input seems to come from here, right? The input comes from here. There's a mirror here. There's a mirror. I'm getting a message. Oh, a voice message? Oh, I'm getting so many messages simultaneously. Okay, I'm gonna have to put you guys on mute for a second so I can hear the message. 1 second.
What? What do you want?
Okay, I need to reply. Well, I cannot talk to her right now. And this one. Okay, 1 second. Hold on. Oh, okay, okay. Okay, let's finish up. Come on. So, okay. Where were we? Okay, this interferometer, right? So it says a viewing screen, Michelson. Okay, this is the viewing screen. So compensator. Okay, what is this? Movable mirror. Okay, this is a mirror. So we need a mirror. We need two mirrors. I'm assuming this is the input. The input. This is a half mirror. Half should go here, and half should go here, and then come back, and then go here. Wait. Oh, sorry. So this is the input. The left is the input. Input, split. So this is one mirror. Come back. And this is the other mirror. Come back. And this is the viewing screen. Okay, okay. So here you put the view. They removed the viewing screen so it hits the wall. Okay, there's more things you can put here. That's fine. Viewing screen. You can also view what comes through. Maybe here you can view it. That's nice. It's fine. But there's no input on board and there's no viewing on board. But you can have, okay, that's good. That's a good device. Incoming light is split into two paths. Good. Good. The relative phases of the waves depend on the length of their respective paths. Right, but they assume that there is no ether. They assume properly because it's flat. Okay. Then it hits the mirror, then they both go back. So what are they looking for? For certain path lengths, the waves are in phase when recombine and constructively interfere. Well, when you want to calibrate it to get basically no interference. So you just want to get a light beam with minimal interference. So you set the distance. So this is the movable mirror. No, this is the micrometer. So this moves this forward. This whole thing moves forward, I think. Are they going to explain it? When one of the paths is shortened by a distance of 1/4 wavelength, you get an interference pattern. Now, this would happen if one of these is faster. The question is, what's going to happen if we're talking about incredible speeds? Well, it doesn't matter. I mean, it's going to make it. If it's 1/10 the speed of light, then it's going to be moving one. It's going to be moving. Well, instead of the speed of light, it's actually going to be moving faster than the speed of light. It's actually moving faster than the speed of light because the space through us right now is flowing faster than the speed of light. Yeah, okay. That doesn't make a difference. The difference is just going to be the interference. It's not going to influence light. So why is it when we point light upwards and downwards, it doesn't change the frequency. Then nothing happens. We don't notice it. Why are we not noticing it? Like when we look up, it should feel different than when we look forward. We should get interference in our lives, shouldn't we? Well, no. So we never compare. We only look at one direction. We never have two beams simultaneously to interfere with each other. We never use the Michelson-Morley experiment in real life. So you never get an interference pattern. As long as you fire one beam, there's no problem. The problem only happens with this device. This device, the only way to get the interference is with this device. La la la. Okay, the relative phase between the waves differs by pi. Oh, what? How did you do that? The input? That's impossible. So, but how? Oh, the mirror. He moved the waves destructively interfere. What does that look like? The mirror is moved until the original interference pattern appears again. Right. So you move. That was the tape. You move from one wavefront to the next wavefront. So these are the two mirrors. This is the semi-mirror. I think this is the half mirror. So d is equal to d naught minus 1/4 wavelength. So you took d naught, the original d, and you moved it forward by 1/4 of a wavelength. And when you did that, you created the difference of it's exactly interfering. It's perfect destructive interference. La 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 la. We're almost done. Oh, the mirror is moved until the original interference appears again. So this is d1/4, d1/2. It goes back to the original. So every 1/2 lambda, you get the original because lambda is a full cycle. The distance the path is shortened corresponds to 1/2 wavelength. The distance the path is shortened corresponds to 1/2 of a wavelength. Okay, yeah. La 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 la. Okay, so I mean, as long as we have the question is, can I put my hands on a interferometer that has everything built in? So this is the interferometer. The following interferometer I can already see is too big.
Interferometer. Aim. To determine the wavelength of the laser,
Determine.
Michelson
To determine.
interferometer and refractive index of the thin film.
That's useless because this table I'm not going to be able to put vertically and rotate it. So this setup is useless, unfortunately. Unfortunately. Wait, how did we get to this video? What happened? Oh, it was automatic? Automatic. Okay. So the Michelson interferometer.
Interference patterns show up very small path length differences as bright and dark patches, whose spacing.
Yeah, but they don't actually have the experiment. This is also just I don't like animations. This is useless because it's on a table. It's huge. You cannot rotate. You cannot put it vertically. Okay, exploring white light interferometry. This seems to be useless.
The phases, and with it we can measure height variations in the nanometer range. The method is commonly referred to as white light interferometry or coherent scanning interferometry. At first glance, the two names seem to contradict each other, as coherent
longitudinal wave like this.
Suppose we start in Canberra and we take a big trip across the Pacific Ocean to the United States. And on the west coast of the United States, in Washington State, is a place called Hanford. Now, the Hanford site is famous for being the place where the Americans made plutonium to put in the first nuclear weapons. Now it's a big nuclear waste dump, and you can still take a tour of it, I gather. Nearby is a far safer scientific facility, This is a giant Michelson interferometer. That white building there contains a beam splitter and a laser. The laser is split into two parts. One is sent along this 4-kilometer long pipe that's pumped down to a high vacuum. The other part of the laser is sent along this other 4-kilometer long pipe, which is at right angles. The lasers bounce off mirrors at the ends of the pipe and recombine at the beam splitter to form the interferometer. This is what it kind of looks like on the inside. There's the laser bouncing off the mirrors. And what we're detecting here with this interferometer is relative motion of the two mirrors. The light, which is split in half by the beam splitter, travels along to the mirrors and bounces off the mirrors. And because the distance the light travels depends on how far these mirrors are away, the interference condition will change depending on the relative length of the arms of the Michelson. So if these two mirrors start moving, then we see constructive and destructive interference.
Hey Karen, what's up? Your mic is muted. La 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 la. Are you gonna talk? La 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 la. Le la la.
Singing.
I am an angel singing, but my angel left me. My chick left me. I mean, not final, but it's terrible. It's absolutely
Wait.
terrible. What?
It hasn't been a week.
What?
It hasn't even been a week.
Yeah, it's whatever. What can
Wait,
I-
are you still streaming?
Yeah. I'm in the middle of. I'm reviewing Michael. I need to prepare for. I want to prepare.
Well, we're not going to talk about your chick then. Oh shit!
Have
Hey,
you been?
did you get my message?
No. Where on this?
Check your private message.
My what? DM?
There's an check your D. And can you not hear me?
Yeah. Yeah, I can hear you. I can hear.
Check your DM.
Okay.
I sent you an article.
An article? You mean everything I'm saying has already been said?
Mm,
I don't see it. Wait. Oh, maybe here. Well, that's just one. Only messages from. Oh, there it is. Okay. Quantum state in a lab has produced something which is mathematical intuition. Yeah, I actually read that today. I saw it.
okay, you've already seen it.
Yeah. That's nothing to do, as far as I remember, nothing to do with me. Like, I am. I mean, it's
But the title of the article is about gravity waves.
yes, it's good. They're saying that they can detect, that they can see that neutrons experience gravity, and then they fall and hit the ground and create shock waves. They think are gravity waves. That's amazing. So that just supports my theory that because everybody says we don't have quantum theory, we don't have a quantum theory for the tiny, which is a lie. General relativity is correct for tiny particles. And they say no, it doesn't work. It contradicts. I don't know what they want. So this is just more evidence that general relativity fits the quantum world, and that's what I always.
Well,
Go ahead.
they admit in the article that it's very, very hard for them to even replicate what they're saying
It's not
because
it's not important. I'm not depending on anything like that. I don't care. I don't need state of the art science to know what I know. What I know is what Einstein knew. I'm just saying.
yeah, but don't you need to be able to duplicate a theory or in order to prove it that it's like a law, like according to scientific method?
Whatever. So tomorrow, that's why I'm studying right now how to work with an interferometer so I can run the experiment.
Awesome. Yeah, I listened to you talk about that today, and I look forward to seeing your results.
I mean, anyone who's listening to me can run the experiment and just write it in the comments. Ti-da-da, la 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 la.
I think you're losing your mind.
I think no. Why would I lose my mind? Da-da-da-da.
Because you're streaming way too much lately.
Look, I want to get this Nobel Prize. It's like $1 million+
It's
dollars.
a Nobel. It's a Nobel.
What?
It's a Nobel Prize.
Nobel. Nobel. Noble.
Noble.
No.
Noble.
It's a bubble. It's a bubble prize. I want to get the Nobel Prize and get all. I don't care so much. The accolades would be good, but I want to get all the chicks and all the money and all the gifts. So well, I don't want to miss it. There's a lot of money at stake. There's a lot at stake. I don't want to lose this. This is a good opportunity to make make something.
Yeah, but you stream so much that I can't watch all of the content because I'm working most of the time.
Look, you can skip some stuff to keep up, and later if you want. Look, a lot of
I'm
it.
complaining. I'm complaining, Mr. Slade, that you're putting out too much content.
Look, most of it is like sciencey, schmeinsey. Do you care? Can you follow it?
I can.
Good. All right. I mean, that's good. If you can follow it, look, it's not complicated. It's like it's just a lot. It's just a lot to absorb. It just there's a lot of terms, terminology, and stuff.
Yeah. You got really frustrated with that one person earlier.
His audio,
Because
his audio drove me insane. Then he tells me, yeah, every time I was yelling, stop, 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 he kept ignoring me. Why do people on Discord behave this way?
you couldn't get him to say whether or not he understood the statements you were making,
Right, but at the
or
end,
whether or not he agreed and disagreed, or understood and agreed.
yeah. No, but at the end, we figured it out. Like he conceded that everything makes sense.
I don't think people aren't used to you because you back them into a corner with your logic, with your debate logic. And they're used to doing all kinds of different fallacies in
Yeah,
order to,
yeah,
dance around the truth. And you go, no, I don't want you to appeal to authority. No, I don't want you to talk about this, that, and the other. I need you to do this, yes or no. And then you strip away all of the smoke
yeah,
and you get down to the topic.
yeah,
That's very interesting. It's a
yeah,
very interesting strategy. But by the time you get there, most people have already assumed that you're a troll or something like that.
yeah. Whatever.
Like,
They can assume whatever they want, but I'm trying to have a discussion with the other guy, and I need to get either give me a concession, either submit or prove me wrong. Either you win or I win. I don't know any other in between. So I kept asking him, so how, like the same question. Einstein came in order to explain why the apple suddenly starts accelerating of its own volition. It's accelerating towards the ground. So Einstein explained it. What's the explanation? Oh, it's curvature.
well, that's easy because the Earth is flat and
Yeah,
the Earth is going upward at 14 meters per second.
exactly. See?
Any other questions?
Yeah, I know. It's so simple.
Hey, you're I'm joking, by the way. I can't believe that you and Judas got into a fairly heated not really argument, but Judas is finally showing his teeth in a debate, and it was very interesting.
Yeah. So from day one, I realized he is underselling his abilities in philosophy.
No, but you and Judas were going back and forth, and you were both getting very very heated today.
Okay,
It's very interesting.
right, but I told him, look, it's a very simple discussion, and so the question is, I don't remember what the topic, but I asked him, so are your thoughts a product of your brain? And he goes, I don't have an answer. Then I said, fine, then let's halt the discussion until such time that you have an answer. And he goes, no, I don't have to give you an answer. It's like, all right, whatever. You can say whatever you want, but I need look, you're coming to me. What is the proposition? You're proposing a new idea to me. You're trying to sell me something. So I'm just trying to understand what that thing is. And as I'm trying to understand, I'm asking you questions. You're telling me you don't want to answer the question. So what do you, okay, so I'm halting the sale until such time that you decide to answer the question. You're trying to sell me something. I'm asking you questions about the thing that you're trying to sell me. And you're refusing to answer the question. So you're holding the discussion, the debate. They're fine. I'm not saying I won, you won. I'm not talking in those terms. I'm just saying then he says, no, I'm holding it. He accused me of holding the debate. So I said, okay, fine, whatever. I don't care. I'm not here to win. So I feel like I did my best to explain to you my position. Yeah, so he says that if you were a brain in a vat, you could still figure out math and logic. I told him I used to think that. I used to think that, but today, now that I know how the brain works, that's ridiculous. And he goes, anyway. I told him, why don't you learn how the brain works and come back? I'm not rushing you. Take your time, learn how the brain works, come back. We'll have a discussion. But you don't know what thinking is. You're talking about what thinking is, right? What was the topic? Is math and logic, like, can you know it without experience? Okay, but what does it mean to know? You need to have a theory of knowledge. How does the brain know? And he says, I don't need to know. I don't owe you an answer. Okay, then then the discussion, as far as I'm concerned, is halted. What do you mean by know? Can you know? Well, you need to know what it means to know. Sorry for the double meaning, but you actually need to know what it means to know. You have to have a know theory, a knowing theory, a brain theory. You have to have it, a fully functional brain theory, like a scientific theory, in order to have a discussion. Can you know math and logic with no experience? Obviously, I believe you can't, because I actually know how the brain works. Anyway.
Well, did you end up? So I actually didn't catch the end of your all's debate. Did you all part on good terms, or what?
Of course.
Okay, so he'll be back.
Of course, I would never fire him from his job.
Wait, what's his job? Have you replaced me? Have I been replaced and I don't know about it?
You've been replaced many, many years ago. Of course, you don't want to stream with me. You're afraid to stream with me. Okay, I'm gonna sing you a song. It goes like this: Ti la la, la 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 la. La 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 la. I need to learn Spanish. I need to learn the words for this song. Anyway, so are you free? Are you free at last?
Yeah, I mean, I can talk to you. We already had this conversation. I can talk to you about anything except for that one topic that you and I do not want to discuss.
I don't discuss it either. That topic is it's out of control. We cannot discuss it.
Yeah. But I don't want to interrupt what you're currently doing. I thought that you were done streaming because you were alone in the voice chat. So
I'm always alone in the voice chat and in the streaming and in the StreamYard.
No, you're not. You're not always alone. There's sometimes people in here talking to you.
Very few times.
Remember that day where you had to, where Mandible refused to leave, and you, me, and Judas had to go into a private.
But that day, the next day, I started studying quantum mechanics and then relativity. That was the most formative debate of my life.
That
Yes, that definitely.
see, I'm not sure if mandibles is worth that accreditation.
Right,
Because whenever you're giving your Nobel speech,
Nobel, Nobels.
well, oh no, now you're going to correct me.
I,
I'm using your language.
you're gonna give my Nobel speech because I'm gonna remain anonymous. You're gonna go there, pick up my check. You go
That's hilarious.
Can you imagine? You go get to say you go make the speech.
Yeah, yeah. And then I'll get arrested for fraud because I'll have your check, and then I'll go to prison.
Ah,
That's funny.
yeah.
And then Judas cashes it, and we don't get anything. It's like, what the fuck?
No, you know what I can go with the ski mask. Imagine I go and take the prize with the ski mask. Oh my god, that's gonna be so funny.
Accept the award. Everybody's clapping, and it looks like you're robbing everyone.
Wait, it looks like what?
All right, everyone. I would like to thank you for this Nobel Prize. Now, if you could please all stand up and empty your pockets. All watches, please empty those as well. Pass them to your right. Thank you. All right, and put them in the bag. Put them in the bag.
What are you talking about? No, I'm gonna be with the ski mask because I want to be anonymous.
I know.
Oh.
But it would also be historic if you accepted a Nobel Prize and also robbed everyone in the audience.
No, no. Some people have done this. People have received awards and used the opportunity to to steal. Anyway, no, I'm not gonna steal, but I'm gonna send you, or but we'll go together. You'll be my partner, and I'll be wearing a mask so they don't recognize me. The question is, what if somebody pulls the mask off? What should I do? I'm gonna need to cover my face quickly.
That's why you have another mask on.
Oh, the double mask trick.
Yeah, kind of like the double slit experiment.
Oh my god. Anyway, this is gonna be so fun.
Yeah, yeah, it'll be fine, and yeah, it'll be great. And make sure that you add a part about mandibles and be like, mandibles,
thank
fuck you. Fuck
Alright,
you,
it's
mandibles.
gonna be a
We
fun.
win. We win.
It's
You
gonna be.
lose.
It's gonna be a very long fuck you speech. I'm gonna tell everyone. No, I'm not. I'm probably gonna start crying because I've been so emotional lately. Jesus, I'm gonna start crying so much. Oh my god, it's gonna
Aw.
be so sad. I'm gonna start sobbing. Oh, oh my god, it's gonna be. I'm not gonna be able to hold my tears. No way. It's gonna be too emotional. I remember Higgs when he was sitting in the audience as they showed the results and he started crying. Jesus, it's too much. It's overwhelming. Like I spent 1 week on this, barely like I don't know 20 hours on this, and yeah, very sad. It's gonna
And
be.
you feel like you have a breakthrough.
What do you mean? I feel like. Well, wait. Are me and you gonna have the same discussion as me and Tysca, whatever his name is? What do you mean I feel like? What do you feel like? Forget about me. What do you feel?
I feel like making love. Dun, 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 dun. It's a song. Anyway.
Yeah.
All right, I'll leave you to it. I'm about to go to bed. So have fun breaking the laws of everything and throwing Einstein in the trash. Einstein.
Einstein. Well, at least I'm pronouncing his name right, you know?
Einstein. Oh my god.
Yeah.
And the way that you say COVID, the way that you talk about the
No,
corona,
don't say
the
schmovid. You're supposed to say
schmo,
pandemic. Schmovic
schmovid.
pandemic. I'm gonna make the speech. Oh, I'm gonna stream live my reception at the Nobel. I'm gonna stream it live on my channel. That would be funny.
And the schmovid pandemic
No, it's
and Judas.
schmandemic. The schmovich mandemic.
Schmovid pandemic. You need to, God, I need like a vocabulary for you.
Yeah,
The
you
schmovid pandemic.
every word they don't allow you to say, you just put an sh in, like whatever you say, schmo, shme, shme. It's like in Futurama, one of the long form. You remember? Did you watch Futurama?
I have watched a few episodes.
No, no, you have to be a fan. So if you're a fan of Futurama, so they had a bunch of movies made, and in one of them they had Shmi. I forgot his name. Like there was a monster the size of the entire universe. A monster the size of the universe that put its tentacles up everybody's buttocks, their ice holes, and controlled and mind controlled everyone in the universe. So its name was something that starts with sh, like okay, I don't remember. Whatever. Anyway, yeah, it's gonna be. I'm gonna try and make sure that it's a really really funny Nobel Prize reception.
Do they give you money?
Yeah, it's like it's $1.25 or something.
Oh wow.
Yeah,
That's good. You'll be able to buy some McDonald's with that.
well, mostly I'll be able to buy mostly chicks. That's the plan. The plan is burn it on chicks.
Oh God. That should just be your entire speech. I would like to thank everyone.
Yeah.
I'm going to now use this money on chicks. Goodbye. Throw off the mic.
Yeah.
That's it.
Yeah, it's gonna be funny. Yeah, it's gonna be a funny day, and that was a funny day.
I look forward to it, and I honestly hope that it does happen for you. I hope that you've been through a lot, especially here on YouTube.
Yeah.
So I hope that you get what you're looking for. So
I never looked for that. I mean, that came it came to me out of from out of nowhere. I never planned on that. I planned to just for YouTube to be a pastime for while I'm doing my work, my actual day work, my day job.
right.
And then I had to take time out. Like 1 week, I had to take time out to figure out all of modern physics. Yeah.
You need to take time off to solve the fucking universe.
Yeah.
Gee. Well, you have a good night, and I will see you tomorrow.
Great. All right, Karen. See you tomorrow. Bye.
Bye.
La 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 la. Dee la la. La 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 la. All right, back to reality. Oops, there goes gravity. Oops, there. Okay. Moving one mirror in my average energy. Oh, that's good. The energy is high school? They teach this in high school?
And welcome to High School Physics Explained. And today I would like to talk about one of the most famous experiments moving in that direction, light source going through this half-silver mirror beam does.
Anyway, enough background. Let's return to the zygo interferometer itself, that lasers have a long wavefront in a second. Because in the end,
okay, I'm tired. So I see a lot of these interferometers are too big. So I hope I put my hands on a tiny interferometer, or I'll just build one. Oh my god. Maybe tomorrow I'll just build one and that's it. It just needs to be really accurate. So I need this micrometer. The micrometer alone, where would I get that? That's like a headache to get. Okay. All right. Interference from two sources. I don't see an interferometer. Applied optics. So I need to go to the applied optics lab to look for this. This is one of the turning points. This lecture, Inductica, definitely worth your time.
For those of you unfamiliar, the Michelson-Morley experiment was an ingenious.
Okay. Okay. Oh, look at that. I think this is the laser beam, so this is no good, no good. No good, no good. This is too big. Everything here. Yeah. This is stuck to the table, I think. Okay, this might be good. Okay, I'm gonna have to just go and look, you know? And that's it. That's useless. How would we need to calibrate it and then flip it. You cannot calibrate it. No, you actually don't have to. You just need to rotate the entire device and see that the interference changes as you rotate the entire device vertically. Yeah. Okay, here's an interferometer. Yeah, it's gonna be too big. I can barely breathe. My breathing has stopped. Same problem. Laser, everything is separate, useless. It needs to be one device. Mhm. This is do it yourself on a table. I cannot do that. I need it to be in a device. Okay, wait. I don't know what to do. I don't know what to do. Unless you take this setup and you put it vertically and rotate it. I mean, if we have no choice, we might end up doing that. Yeah, so the speed that it is even 6 million, let's say around 6 million meters per second, that shouldn't be a problem because right now I'm looking up and I'm not noticing an issue. Looking forward, up, there's no difference. The difference will be if you split the beam, and then you'll get a speed up going down and then a slowdown going up. And that's going to be more than just a small deflection. So it should create a wave interference, I think. All right, I'm going to go to sleep. I'm tired. Me tired. Oh, no. Forget it. Okay, we're wasting time. All right, everyone. Thank you very much for joining me on this wonderful, wonderful voyage. It's a voyage. All right, good night.